Imagine you're stepping on board a once-in-a-lifetime Arctic expedition that departs to the east coast of Cape Bathurst in Canada's Northwest Territories. It's said that the location you're headed is unmatched on planet Earth. The final destination is an unbelievable location known as Smoking Hills. These red-striped rocks have been burning there continuously for centuries. It has minerals there that are only found outside our planet, on Mars. Some scientists even believe that the site can be an important case study for discovering life on the red planet. On board the small cruiser ship, you head out to the deck and spot an unusual scene on the horizon. You see clouds of smoke forming close to a seaside hill. It's as if a party of hundreds of people did campfires all at the same time. But this smoke is not man-made, your guide tells you. Naturally, most people guess it's a volcano. Some people on the deck even guess that an eruption might happen anytime soon by the looks of it. Your guide laughs, explaining that this is far from the case. Volcanoes are usually found on the edge of tectonic plates. It's a rupture on the crust of the Earth that allows hot lava and gases to escape to the surface. In the Smoking Hills, the story is different. The constant smoke is caused by a natural phenomenon. But you'll learn all about it over the next few days. As strange as it may sound, these rocks didn't begin burning yesterday. According to experts, the ground on Smoking Hills has been releasing clouds of smoke for at least a couple hundred years, non-stop. You heard it right. But experts are still unsure how long they've been burning. It could be thousands of years. Now, before you leave the ship, some instructions are in order. The expedition leader explains you're going to enter a high-risk place. So, we replace your regular hiking boots and clothes with a special suit and gas mask before stepping on site. The clouds of smoke you are now watching from a safe distance are composed of sulfuric acid. This chemical is highly toxic. You need to be careful while breathing its air. So remember to keep those masks on. Oh, and as tempting as it may look, don't touch anything with your bare hands. Legend says that the first crew to explore the Smoking Hills found it by mistake. And imagine, these people had none of the gear you're going to use. First written records on the Smoking Hills date back to the 1800s. Irish explorer Captain Robert McClure led an expedition to find the lost explorer Sir John Franklin and had disappeared for over 5 years. The crew took a wrong left along the way and stumbled upon these burning rocks. They also thought it was an active volcano, much like you did, but they discovered how wrong they were when they stepped on site. McClure got curious and took a sample rock back to the boat, and the story says it burnt a hole through his mahogany desk. Remember this when you feel like taking a souvenir home with you. It might not burn a hole on your desk, but it sure will fly through your pocket or any container you try to use to take it. Now, it's day 2, and you're ready to explore the location. The expedition's crew is divided into smaller boats. On your way to the shore, you notice a group of animals. They are far from the smoke, and it looks like they have themselves a mealtime. The Smoking Hills are located in the Arctic tundra, and there are rich fauna and flora nearby. Slowly, you're approaching the shore. Now you see the cliffs are made of red-striped rocks that look like they've been hand-painted by someone. There's another place on Earth with similar hills, and it is located in Peru, all the way to South America. The so-called Rainbow Mountain or Seven-Colored Mountain is a mesmerizing natural phenomenon. They are formed by the sediment of different materials. While the Smoking Hills are mainly red, over in Peru, these mountains have stripes of lavender, gold, red, and even turquoise. When you finally leave the boat on the foot of the Smoking Hills, you begin your hike up. Stepping is difficult with your special boots. The soles are made specially to support high-degree temperatures, but it sure is hard to keep your balance. Before you know it, you're as close to the burning rocks as you can get. Your first impression is to get out of there as fast as possible. Conditions for human life are harsh over there. It's inhospitable, and everything about the place says you shouldn't stay for long. but you are also beyond curious. You might ask yourself how these rocks keep burning for so long. The science behind it is not too complicated. The rocks you're looking at are called shales. They are a type of sedimentary rock formed by clay minerals. Your guide explains that the secret to the smoke lies on the ground. The soil is formed by sulfur and coal. When they get in contact with oxygen, they spontaneously ignite, releasing the smoke you're now seeing. The few ponds in the region have very acidic water. Scientists say that this world region is the only one to show a negative pH. It means this water is naturally corrosive, so you don't dare drink it. Make sure to bring your own water bottle when leaving the ship. You spend a few hours there, but it seems like a whole day. The suits are heavy, and breathing through a gas mask is not your idea of comfort. At the end of the day, you head back to the ship, enjoying a beautiful Arctic sunset on the way. On the morning of your third day, you're in for a nice surprise. You're not heading out again. Instead, you're going to take a trip to outer space. Metaphorically, of course. Your guide talks about the connection between the smoking hills and Mars. Looking for life on Mars has been a journey all on its own, but recently, scientists discovered the exciting presence of jarosite on the smoking hills. And guess what? Jarosite is an abundant mineral on Mars. Experts think that this may indicate that Mars did have running water at some point in the past, since jarosite needs groundwater to form. This huge discovery may take science many steps closer to a breakthrough. Has life really existed on other planets in the solar system? Mars has been on the map for scientific research for being the most likely planet to have developed life. The atmospheric temperature now is unbearable for above-ground life, but it was similar to Earth's at some point. The most important proof needed is to find the evidence of running water. Right now, as we speak, the Curiosity rover is out there looking for any piece of information that can hint at the existence of life on Mars, past or present. Just out of curiosity. Curiosity, the rover has been exploring the surface of Mars for over 3,566 days so far. If you do the math, it makes for 9 years and 279 days. And in case you're wondering, why are we so eager to find life on other planets? According to NASA, the research for life on other planets can help us explain a lot about our own history. Where we came from, and maybe even where we're headed. And who could have guessed that scientists could begin to find answers for that in the Arctic tundra? That's exciting, right? Now, it's day 4 aboard the ship, and the expedition is coming to an end. Time to head back to mainland Canada. You just visited one of the world's most inhospitable places with a lot of impressions. Now, it's time to tell us what you thought about the journey and what you learned along the way. Write it all down in the comments below.
Mars is a dry, rocky, and barren planet. It's difficult to imagine that once upon a time, the red planet could have had a landscape similar to ours. But scientists believe that this is the case and that millions of years ago, Mars was filled with vast oceans of water. In early 2021, NASA sent their most advanced rover yet to the red planet. Its mission is to search for any signs of microbial life that hint at the planet's past. They named the rover Perseverance, or Percy for short. Even Percy's initial landing on Mars itself was a scientific discovery. The rover landed using auto-navigation along with onboard cameras to track the planet's surface and find the ideal spot to land. This helped scientists work out the best landing options for future missions to Mars. Percy currently roams the red planet, guided by a new and highly advanced auto-navigational system. The majority of his day is spent analyzing rock formations. Percy is decked out with a high-tech laser that fires a tiny pinpoint beam into rocks. The laser creates a plasma from the rock samples. Then Percy's onboard spectrograph analyzes the plasma to identify the chemical composition of the rock. 2 of Percy's most significant findings so far are rocks that have been nicknamed Mazi and Yigo. These words come from the Navajo dialect, in tribute to a NASA engineer from the Native American Navajo tribe. Mazi means Mars, and Yigo means diligent. These two rocks are both salt-like in composition, meaning they are igneous rocks. If you're not familiar with your rock species, igneous means that the rocks were formed from a volcanic eruption. The current shape of Mazi and Ego suggests that they have been molded by a watery environment. This could be proof that Mars was once filled with water. Another interesting rock discovered has been nicknamed the Harbor Seal. This is a dark, smooth rock that scientists believe had been sculpted by powerful northwesterly winds to resemble the playful marine animal. For decades, scientists have theorized about the wind and weather patterns on Mars. This finding seems to support their existing weather modeling of the planet. Percy has sent back over 20,000 images since arriving on Mars in February, including an internet-breaking selfie. Audio files have also been sent from the Mars mission. For the first time ever, we can listen in to the eerily and ambient sounds of extraterrestrial winds on the Martian landscape, all thanks to the rover's onboard microphones. For the first time ever, oxygen has been produced using human technology on another planet. Inside Percy is a gold-plated box around the same size as a car battery. This is the MOXIE unit. MOXIE stands for Mars Oxygen In Situ Resource Utilization Experiment. Yeah, that's a bit of a mouthful. 95% of Mars' atmosphere consists of carbon dioxide. The MOXIE unit diffuses the carbon dioxide and, through an intricate chemical process, turns it into oxygen. The unit has produced a modest but still historic 5 grams of oxygen. This works out to around 10 minutes of breathable air. It's also a good sign for what could come in the future. Who knows? Maybe one day MOXIE can produce enough oxygen to support a human colony on Mars. For now, scientists are more focused on MOXIE producing enough oxygen to create rocket fuel. In order to propel the standard-sized modern-day spacecraft off of Mars, you would need 7 metric tons of rocket fuel and 25 metric tons of oxygen. This would be far too heavy for a spacecraft to bring from Earth. So, if there is ever to be a manned mission to and from Mars, there needs to be some way to create fuel on the planet. For those of you worried about Percy being lonely, he actually has a special companion up there with him. Stowed inside the rover on his descent to Mars was a small but expensive helicopter named Ingenuity, but you can call her Ginny for short. The mini-helicopter cost NASA $80 million to develop, but every penny was worth it as Ginny made history by performing the first powered drone flight on another world. Ginny was a massive scientific feat, as engineers originally struggled to design a helicopter dinky enough to be stowed on an interplanetary rover, but powerful enough to take flight on another planet. After the success of Ginny, scientists are now collecting data from the one-of-a-kind helicopter to aid in the design of smart micro-drones here on Earth. The helicopter is used to explore terrain that is unsuitable for the rover. Ginny hovers over the Martian landscape, collecting data and taking aerial photographs to send back to Earth. Ginny is powered by solar panels above the rotor blades. A big concern for scientists was that the panels would get covered in thick coatings of Martian dust and leave the helicopter powerless. Luckily, airflow from the blades actually self-cleans Ginny's solar panels. Inside her mechanisms, Ginny carries a small postage stamp-sized piece of fabric from the Wright brothers' historic 1903 flying airplane. This is a loving tribute to the original pioneers of aviation. The Curiosity rover first landed on Mars back in 2012 and has been roaming the red planet for over 12 years. Curiosity wasn't designed to detect life as Perseverance was, but instead to determine if Mars had any of the necessary elements that could sustain life. This includes things such as liquid water, carbon, energy sources. Curiosity found a site scientists called Yellowknife Bay. This site once contained an ancient lake. The rover discovered minerals left behind from the waters, showing that the lake water was not too acidic or too salty. It would have had a balanced pH. Carbon, nitrogen, and other elements that could potentially support life were all found within the crater of the ancient lake. And most important of all, Curiosity found potential sources of energy for microbial life. So maybe there could be existing life on Mars after all. Curiosity made history by being the first Mars rover to witness and measure a planetary-wide dust storm. Just like on Earth, wind constantly blows on Mars, grinding away at the geology. This creates lots of dust, which eventually gets whipped up into large clouds. The dust clouds absorb sunlight and heat up, making the winds more intense. Without any rain or oceans, every few years the clouds grow so large that they wrap around the entire planet and create a giant dust storm. In 2018, Curiosity witnessed one of these great storms from the Martian surface. It noted that sunlight on the planet decreased by 97%, and many large sand dunes were left behind. Curiosity has spent more than a decade measuring the radiation environment on Mars. This allows scientists to work out if humans could safely visit the red planet without turning radioactive. So far, the news is encouraging, and the Mars radiation levels are comparable to those experienced by astronauts aboard the International Space Station. This means that astronauts could endure a long-term round trip without having to worry about radiation too much. Mars is home to the largest volcano in the solar system, Olympus Mons. This giant volcano is 14 miles high. That's about 2.5 times the size of Mount Everest. The volcano was formed millions of years ago, a time when Mars was filled with countless volcanoes, spewing molten lava across the planet's surface. Olympus Mons is a shield volcano, so rather than violently spewing lava and flames up into the air, lava would flow slowly down the sides of the volcano. This gives it its low, squat appearance and an average slope of only 5%. At only a few million years old, Olympus Mons is still a fairly young volcano. Because of this, scientists believe that it could potentially still be active, so maybe it could erupt at some point in the future. The Curiosity rover doesn't just eye up the local geology, it also takes a note of what's happening in the sky. In March 2021, it captured these shimmering iridescent colors in the sky, named mother-of-pearl clouds. This colorful display occurs when all the cloud particles are nearly identical in size. It usually happens shortly after the clouds have formed. Imagine something terrible happening to Earth and humans having to leave it as fast as possible, and you have to decide which planet will become your new home. Which one will you pick? Probably the first planet that comes to mind is Mars. It's relatively close. Like Earth, it's also a rocky planet. It even has an atmosphere, even though it's much thinner than what we have on our planet. But at the same time, the North Pole on Earth would seem balmy to you in comparison to Mars. On the red planet, the average temperature is minus 80 degrees Fahrenheit. The most radioactive areas on our home planet might seem harmless if you compare them with the surface of Mars. But what if we terraform Mars? Could we keep transforming the red planet until it becomes capable of supporting human life? It would be an enormous feat. Mars is an extremely dangerous place. Should you teleport there right now, without any protective suit or anything, the gas in your blood would instantly turn into bubbles. You can probably imagine the consequences. Add oxygen deprivation, cold exposure, and radiation poisoning to the equation, and well, who's next? If we still decided to terraform Mars, we would need to create a stronger magnetosphere. We've got this protective magnetic layer on Earth. It shields us from the sun's ultraviolet radiation. The red planet would also need a thicker atmosphere, again for protecting us from harmful space stuff better. Right now, the Martian atmosphere is almost entirely composed of carbon dioxide with tiny amounts of oxygen. For us to live there comfortably, Mars would also need to be warmer. And if we managed to somehow warm the planet up, we'd also be able to release frozen carbon dioxide. At the moment, there are vast reserves of this gas at the red planet's polar caps and other areas. It would help the atmosphere to become thicker, making it possible for water to exist on the surface of the planet. Right now, there is some water on Mars. The atmosphere of the red planet is too thin for this water to stay in its liquid form. But under the surface of the planet, it's a different matter. You can find water under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar Ice Cap. Also, sometimes salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. If liquid water existed on the surface of the planet, it would make it easier for us to start growing plants. And plants, in turn, would begin to produce oxygen. But first of all, we would need to start the warming process. How? Well, Elon Musk suggests using nuclear energy to make Mars more livable. He says it could be done by creating a continuous flow of low-fallout nuclear fusion explosions above the atmosphere of the planet. It could create something like numerous artificial suns. It could warm the planet, melting the frozen ice caps, which would then thicken the atmosphere, causing even more warming. Other strategies for Martian global warming include the diversion of asteroids into the poles of the planet, or the large-scale production of greenhouse gases that could help us heat the red planet. Or we could create a giant space mirror, as huge as the side of Mars. It would reflect tons of additional sunlight onto the planet. The problem is all these projects would have exorbitant costs. They would also require serious upgrades in our technological capabilities. Could there be an easier and cheaper way of terraforming the red planet? It seems so. Casey Hanmer used to work in NASA's Jet Propulsion Laboratory. Now he's the founder of a startup hoping to create carbon-negative natural gas by pulling carbon dioxide out of the atmosphere of our planet. He's also made a proposal to terraform Mars for a modest $10 billion. Sounds alluring. So, what is his idea? Mass-produced small solar sails. These are already existing technologies, even though they appeared only recently. Such sails use sunlight to propel themselves, like ships use the wind to sail. These solar sails could be launched into low Earth orbit, and after that, they would fly themselves to Mars. There, they would reflect sunlight onto the night side of the planet. According to Hanmer's calculations, a decade of such launches could result in a 1% increase in temperature on Mars. Hanmer also believes that we could mass-produce solar cells at cell phone factories, all because a solar sail would need a processor, a camera for navigation, and some electronics to be able to transmit data, just like a smartphone. In other words, solar sails would be like small satellites using cell phone technology. Each of these sails would also need a sail of its own, a thin space blanket weighing about 2 pounds. When unfurled, it would span around the size of 2 basketball courts. Would this plan involving solar sails enable people to terraform Mars? Hanmer doesn't think so. Even if we put loads of money into solar sails, they would only make the red planet warmer and more humid, but they still wouldn't be enough to make Mars suitable for human life. Most scientists are also very skeptical about the very idea of terraforming this cold, dry world. They say that carbon dioxide and water vapor are the only greenhouse gases present on Mars, but there's just not enough of them to change the situation. Let's say we manage to melt the polar ice caps with the help of Elon Musk's nuclear technology or solar sails. And still, this ice will only release enough carbon dioxide to bring the atmospheric pressure to 1.2% of what it is on Earth. Plus, most of the carbon dioxide gas wouldn't be accessible, and we wouldn't be able to mobilize it. Even if we decided to go through an energy-intensive process of the extraction of carbon dioxide from the planet's soil, dust, and minerals, we'd still only get the atmosphere to a mere 5% of where it needs to be. Water is another problem. It is salty on Mars. It might even be as salty as the oceans on our planet. But these salts aren't what you find on Earth. If a person consumed a certain amount of them, they would be highly toxic to the human body. Who's next? On our planet, these salts are formed as byproducts of rocket fuel, as well as in road flares and fireworks. Naturally, they only occur in very dry areas. If there are no particular bacteria to break them down, these substances accumulate year after year, and their concentration in water is constantly increasing. But in theory, it's possible to purify even such water. The process of filtration could help the astronauts get rid of 90% of harmful substances. Then they could use a UV disinfection unit. This would also help get rid of any foreign molecules, if there are any, that might be hiding in the water. This stage would not only protect the astronauts, but also prevent them from bringing any dormant Martian microbes back to Earth. In other words, future travelers to Mars shouldn't have too many problems with drinking water on the red planet, but only if they bring the right purification equipment that can deal with any water quality. Because however bad running out of water in the middle of a desert is, experiencing it on another planet sounds much more terrifying. Anyway, back to terraforming the red planet. Once you start thinking about it, some worrying questions arise. Who is supposed to decide whether we should start this process? When should we start it? What if there's some form of life on the red planet, like indigenous microbes we haven't spotted yet, and our attempts to change their home will disturb them? What if they don't survive these changes? Now, what do you think? Share your thoughts in the comments. Millions of people around the world go out on the streets and rooftops to look at the amazing cosmic phenomenon. Another planet right next to the moon, a big red one. At first, everyone's excited. Mars showing up out of nowhere is having a strange effect on humanity. Just as the moon can affect the psychological and physical state of some people, Mars's unexpected visit is causing people to behave pretty strangely. Every night, the sky is lit up by the white light of the moon and the red glow of Mars. Many people get a sort of instant insomnia. Some even stop drinking coffee because they no longer feel sleepy. Mars brings out energy and a little wildness in people, making them laugh more, and even drives a few poor people crazy. They begin to go out of their houses more often and enjoy the unusual night sky. A few days later, everybody can see what's happening. Mars is getting bigger. Scientists announced that the red planet is slowly moving towards Earth. A collision is inevitable. Earthlings only have a few years left. A few months ago, a huge asteroid crashed into the red planet with such force that Mars simply flew out of its own orbit and went rogue. The chance that Mars would fly close to Earth was always going to be pretty high. After about 3 seconds of being announced, the news went viral, and panic set in. The situation's getting worse and worse. The closer Mars gets, the more it affects people on a physical level. Hundreds of videos pop up showing collision simulations of Mars and Earth. And there's no happy ending. Want to see what happens? One famous blogger asked her followers. The Earth's almost completely covered with water, and Mars is all dust, sand, and rocks. Then she puts a huge watermelon in the middle of her room. From the far end, she launches a bowling ball at it. Strike! Mars looks almost the same size as the Moon now. It's about to come into the Moon's orbit, and it's affecting the Earth's magnetic field. Floods, hurricanes, tsunamis, powerful thunderstorms. They go from bad to worse. Animals go crazy. Birds no longer migrate south. The polar northern lights appear in the Caribbean. The economy isn't handling the news that well. People stop showing up to work. Why wouldn't they? They just want to have fun and be with loved ones. There are enough resources on the planet to last until the catastrophe, so no one's even trying to fix the Earth's problems. Clothing, food, cars, yachts, whatever, everything loses its value and becomes free. Every day, huge street parties pop up all over the world. People decide to live their last months in peace and harmony. The global catastrophe is uniting humanity like never before. To go out with a bang, Earthlings team up to organize a huge rock concert. The red giant destroying our beautiful blue planet. Yeah, rock and roll's the perfect soundtrack. There's just enough time to eat, dance, party, and listen to good music. Huge stages are built all over the planet. It's every musician's last concert. During all that preparation, hope suddenly appears. Scientists have calculated all the events that'll occur when Mars crashes into Earth, and they have a simple plan. Luckily, humans had already planned on moving to Mars, so they already have been building spaceships for years. There's no time to get to another planet before the collision, but the good news is that people can wait out the disaster just outside Earth's orbit. You get to sit in a space station, munch some popcorn, relax, and enjoy the show. When the dust settles, it might just be possible to return to Earth, or what's left of it. After learning about this plan, people start working on finishing the ships night and day. Everyone in the world pitches in. There are still 2 years left before the big day. The huge concert stages are converted into more space stations. Mars is now giving people more energy, and with epic teamwork, people manage to create thousands of stations in just a few months. That's what happens when 7 billion people work together. Farmers, physical therapists, chefs, engineers, athletes, accountants, all on the same team. Mars is now closer to us than the Moon. The red giant blocks out the sun, and our planet is plunged into darkness. There are only a few days left. People are working like ants in a massive colony, putting the finishing touches on several 100,000 space stations. It takes 4 whole days for everyone to get on board. Plus, there's the loading of supplies, animals, fish, seeds, plants, vegetables, fruits, video games, fruit roll-ups. The red giant is scheduled to enter Earth's orbit in a couple of days. That's when it will really pick up speed. Mars is only a little more than half the size of Earth, but up in the sky, it looks infinitely huge. The ships start taking off. People take a last look around, memorizing every inch. In a few hours, it'll all change forever. The stations fly up far enough away to clear any orbits. 2 worlds colliding together should still have a soundtrack, though. Rock stars on every ship organize an outer space music festival. To the awesome sound of rock, Mars enters Earth's atmosphere and burns a thin layer of its own surface. This releases an incredible amount of energy. It gets faster and faster and smashes into the Pacific Ocean. A huge blast wave sweeps across the entire planet. Everything is lit up by flames, and everyone on the ships has to put on sunglasses to avoid being blinded. Our blue planet is turning into a fiery one. The dust of Mars mixes with the water of Earth. The force of the impact goes through the Earth's crust into the liquid hot magma. Hundreds of pieces of Mars, some the size of entire countries, are somehow floating in the atmosphere. The collision generates so much energy that all oceans boil and evaporate. Seas and rivers of molten metal are now spreading all over Earth. Days, weeks, months pass. A belt made up of bits of Mars forms around the Earth. It's like a fiery version of Saturn. It'll take a long time before it's safe to land back down, but humanity can't stay alive on the ships all that time. Food, water, and oxygen will run out after a few years. But scientists already have a plan. The ships flip a switch and become huge cryochambers. The ships are equipped with energy panels, and the roasting hot Earth's giving off a lot of energy. Totally enough to keep the ships working while everyone on board takes a few 1,000-year nap. As soon as the planet cools down, humans will wake up. Hundreds of thousands of years pass. One day, alarms go off simultaneously on all the ships. People wake up, slowly. Their bodies are exhausted, but after a few billion cups of coffee, everyone's ready to go. Down on Earth, new continents should have formed, and the atmosphere is most likely way different. The planet might have lost its original orbit, so it might be spinning at a different angle. The seasons as we know them, gone. All the water on Earth evaporated in the first few hours. But there were huge glaciers on Mars, which might have melted on impact. Mars may have shared its water with our planet. The clouds of dust and dirt should have settled by now, and the ground should be pretty good for growing stuff on. All that magma probably spewed up a bunch of useful minerals and chemicals. It's going to be difficult, but humanity somehow must adapt to the new Earth. People are ready for anything. All the Earthlings run to the nearest windows to see what their beloved planet looks like after all these centuries. Where is it? People are craning their necks, looking out at the empty spot where the Earth used to be. The impact of Mars was so strong that it pushed the Earth out of its orbit around the Sun. It's gone. Great. What are we gonna do now? Some bearded guy grabs a guitar and says, "Let's play!" This planet's called the jewel of the solar system. Made up mostly of gases, it could float on water, should you find a reservoir 75,000 miles across and just as deep. But what makes the planet so recognizable is its beautiful rings, gray, tan, and beige. They consist of dust, rocks, and ice. Some bits are as tiny as grains of sand, others as large as skyscrapers. The planet I'm talking about is Saturn, and right now, Earth is hurtling toward it at breakneck speed. It all started on a regular day over half a year ago. All of a sudden, Earth changed the course it had been following for several billion years. But instead of rushing towards the Sun, it started to move away from the star. On second thoughts, it might be for the better. We've got more time to find a solution. Earth used to move around the Sun at a speed of 67,000 miles per hour. For some mysterious reason, when it left its orbit, the speed remained the same. It means we're going to cover 746 million miles, separating our planet from Saturn within a year and 3 months. At first, no one realized what had happened, but a couple of hours later it became obvious. Despite the panic that engulfed Earth's inhabitants, nothing seemed to be out of the ordinary. But all too soon, it started to get colder and colder. Astronomers' forecasts were pessimistic. People started to leave their homes at the poles, move closer to the equator. Most plant and animal species were having a hard time. Some of them went extinct, even though we were trying to save them in greenhouses and special conservation parks. The sky changed dramatically. In a week, we could see Mars clearly. It looked like a big reddish sphere hanging low over our heads. Jupiter became as bright as the moon. Once Earth was as far away from the Sun as Mars, days became twice dimmer than they used to be. At first, our planet's atmosphere was acting as a barrier between people and space. That's why we didn't feel the cold immediately. But 7 days later, everyone who dared to leave their home had to be cocooned in heavy winter clothing. By that time, the temperatures had already dropped down to minus 145 degrees Fahrenheit. It got even colder once our planet passed Mars and hurried through the asteroid belt. It's been one of the most dangerous regions on our way so far. Yes, people could admire awesome meteorite showers streaking the sky. But several space bodies managed to get through the Earth's atmosphere. They slammed into the ground, flattening mountains and leaving behind gigantic craters. They caused tsunamis and triggered earthquakes. Right now, most of the planet, including the oceans, has already turned into an icy desert. There's a lack of food and natural resources. We've built underground towns and tunnels connecting them. Our scientists work day and night to find a way out of this situation. If they don't, that's what's going to happen. The closer our planet will be to Saturn, the more the ringed planet will loom over the horizon and the larger it'll look. Soon, it'll already shine brighter than the full moon. The massive yellowish-brown orb will be visible even during the day, but it'll look especially impressive at night. Instead of sleeping, millions of people will spend hours watching Saturn grow larger and larger. One day, the distance between the two planets will become the same as the distance between Earth and Mars used to be. Saturn's disk will be about a quarter the size of the full moon. Its rings will be as large as 2/3 of our natural satellite. Soon after that, our planet's speed will start to increase under the influence of Saturn's gravitational pull. The ringed planet is 9 times wider than Earth, and its mass is almost 100 times greater. That's why, instead of moving at a speed of 29 miles per second, we'll be dashing through space at almost 40 miles per second. That's 2,400 times the average car speed. Saturn's gravity will influence the moon more than that of Earth. In no time, we'll lose our satellite. It'll get catapulted into outer space, likely to go into an elliptical orbit around the Sun. If Earth wasn't about to crash into Saturn in the nearest future, the moon could one day cross paths with our planet again. No good would come out of such an encounter. But what's happening on Saturn's side of things? Saturn is one of the largest planets in the solar system, second only to Jupiter. Even though the rings surrounding the planet are huge, they're rather thin, less than a mile thick. Still, the main rings are large enough to stretch from Earth to the moon. But how did the planet get these breathtaking accessories? Beyond the outer edge of the main rings, A, B, and C, there's something astronomers call the F ring. Several million years old, it's the weirdest one. This constantly shifting ring is made up of icy material and is incredibly complex. Its curves, twists, and clumps of brighter substance make it look as if it's braided. Saturn has more than 50 confirmed moons. 2 of them, Pandora and Prometheus, flank the F ring on either side. They weave outside and inside the ring, acting like shepherds. They herd ice particles into a 60-mile thick band. But why are they performing this elaborate dance? No one knows. What scientists do know is that when Saturn's rings were evolving, icy material clumped together and formed moonlets. Some of them grew and turned into the planet's largest moons. But 2 of them collided. That's how the mysterious ring F appeared. If the moonlets had only been made up of small icy particles, the space collision would have left a ring and nothing else. But they had dense rocky cores. Those remained intact and turned into Pandora and Prometheus. People don't have any evidence Saturn's ever collided with another space body. Our Earth might be the first. But before crashing into the planet itself, we'll have to get through its rings, including the ring F. And no, our planet won't just punch a hole in them. Saturn's rings are made of small particles. Earth's gravity will start to pull some of them out of their orbit once we're close enough. It'll result in a long plume that will reach our planet. And later, when we squeeze through, the cloud of icy particles will drag after Earth. It won't have enough power to rid Saturn of its rings completely, though. They'll continue to move around their home planet, but their orbits will change and become more elongated. There will be no more stunning bands. Over time, the rings could probably settle down again, but Earth won't give them such a chance. The collision with our planet won't leave Saturn unscathed. If there's still a possibility to sneak a peek at the sky, people will be able to see the rings disappear into nothingness, but not for long. Soon, the largest chunks of rock will start hitting the surface of our planet, leaving behind lifeless land dotted with craters. In the worst-case scenario, Earth might even collide with one of Saturn's numerous moons. But let's imagine we've passed through this region in one piece, and now our planet's very close to Saturn. The gas giant might seem airy, but there's no way Earth can fly through the huge sphere and leave from the other side. Gravity is what keeps all that gas together. The very gravity that make our planet speed up. The closer it is to the much bigger space body, the stronger the pull is. It'll cause the fault lines on Earth to rupture. It'll also set off powerful volcanic eruptions all over the world. And then, with enormous force, our planet will crash into Saturn. The planet's atmospheres will get compressed. This will cause a dramatic and fast temperature rise, and in no time, the air will be on fire. Scientists claim that Saturn's core is dense, made up of iron and nickel, and surrounded by a rocky layer. But we'll never make it there. Earth will burn in the bigger planet's atmosphere after being literally torn apart. Our beautiful, blue-green world will turn into billions of trillions of tons of vaporized rock. Pity. Maybe Earth will become yet another Saturn's ring, instead of the ones it's ruined. Sounds grim, I know. Yeah, we can't save Earth from Saturn, but that's only a bad dream. So maybe we take that effort and save us from a real threat, climate change. Just saying.
It all started with a minor change on our planet. At first, people noticed the moon had become brighter and a little bigger. But nobody paid attention to this. The moon affected tides all over the world. The water flooded the beaches, but it wasn't a tragedy. A lot of fish came close to the shores. People found giant squid, anglerfish, and other creatures next to the coast, although they usually live in the dark depths. New, stranger things happen every day. Birds no longer fly to the south in winter. They gather in huge groups, flying around cities with no purpose. The moon used to help them navigate in nature, so they can't figure out which way to fly anymore. In the boundless waters of the world's oceans, ship captains notice that compasses are now unstable. The arrow is pointing in different directions since the Earth's magnetic poles have changed. people realize the moon has started to approach Earth for an unknown reason. The moon's gravity affects the gravity of our planet. This entails changes in the climate, the behavior of all living beings, and the magnetic field. Now, it rains in the driest places and gets hot in the coldest lands. It's knocking down ecosystems all over the planet. People living near forests hear wolves howling all the time. The moon drives these animals mad. The Earth's natural satellite is growing in size and lights up the night much brighter. Nothing critical has happened yet. People don't panic because they don't want to believe the end is coming. But then, one day, the moon reaches a critical point. You're walking down the street listening to music, and at that moment, someone pushes you. Okay, maybe that guy is late for work. You keep walking, and a girl coming by hits your shoulder. "I'm sorry," she says, and goes away. You've noticed the fear in her eyes. You look ahead and see people running towards you. You take off your headphones and hear screams and sirens. People leave their cars and run away. Hundreds of seagulls are flying in the sky. You hear a strange noise among all the sounds of chaos. It seems to be water. How is this possible? You're in the city center, a few miles from the shore. But there's no time to think. You notice a huge wave flooding the streets and heading straight to you. You run into a building and go up to the 10th floor. From here, you're watching the water filling the city. The strong stream blows all cars, one-story buildings, and trees off the road. You notice a shark and other fish in the water. People are hiding in houses and on the roofs. The whole city is quickly plunging into a catastrophe. The TV is working in the building where you're hiding. You learn that floods are occurring all over the world. Massive tsunamis cover coastal cities. In some places, waves reach the height of a 30-story building. Many towns have been washed off the face of the Earth. The moon is too close to Earth, and massive floods are just the beginning. The moon flies around Earth and helps to keep our home on its axis. The moon provides climate stability and helps living organisms develop. But now, this balance is broken. The moon is approaching and changing our planet's gravity. Earth can tilt slightly to the side and provoke massive floods around the world. Imagine that you're holding a round glass of water. Tilt it a little. See how the liquid moves from one side to another? The same thing is happening now with the oceans. But the moon is not just approaching us. It's flying around the planet and getting closer with each circle. It causes natural disasters in different locations on Earth all the time. Now the ocean floods one side, and a few hours later, another. So you see all the water going back from the streets to the shore. The oceans may return to the city again by the end of the day. Wait a minute. It seems the end of the day has already come. You notice that the sky has become dark. It's weird, because it's only 3 p.m. The moon changes Earth's rotation speed and makes the day go faster. The moon covers almost the entire sky and brightly illuminates our planet. You see huge lunar craters. It's so close that you can still see it even when the sun shines. In some places, the passing moon obscures the sun. The water is leaving the streets and everyone goes outside. At this moment, an earthquake begins. The road is cracking and the houses are collapsing. There are landslides on the street. Tectonic plates are shifting all over the planet. Imagine two magnetic balls that are approaching each other. So, one ball is the moon and the second one is Earth's core. What do you think will happen to what's above the core? That's hundreds of thousands of miles of the Earth's crust. And now, it's all moving. Destructive cracks are emerging all over the world. The planet's highest mountains break down and turn into a pile of stones. The seabed cracks and releases magma from the underground depths. Volcanoes wake up and erupt magma. Clouds of volcanic ash cover the sky from the sun and the glowing moon. But the scariest thing is still ahead. A collision is inevitable. The moon flies around the planet like a ball in a round glass with a hole in the center. This force drives clouds all over the planet. Now there's a thunderstorm, but in 5 minutes, it will be snowing. Then the night comes, and it starts raining. Water droplets consist of mud and volcanic ash. It's difficult for people to breathe without gas masks. Atmospheric pressure is constantly changing. Some people experience severe migraines, and some have sore joints. But there's no time to think about your health. Humanity needs to figure out how to save itself from the collision. A new gravitational order will come when the moon crashes into Earth. Continents will change their shape. They will combine into one giant piece of land or split into 100 smaller ones. The energy of the collision can burn all the oxygen in the atmosphere and make the planet unsuitable for life. Hiding underground also makes no sense because of deep earthquakes. People decide to spend their last hours with loved ones and their families. The moon is getting closer. It's now at the same distance as the International Space Station. The moon covers the sky. Many cities are in the shadows because of the waves. Tsunamis, several miles in height, crash down on the ground. Millions of tons of magma collide with the ocean. Billions of gallons of water just evaporate. Moisture rises into the air, mixes with ash, and floods the land in the form of giant cumulus clouds. You've accepted the complete destruction of the planet, but something strange happens to the moon at this moment. You notice giant cracks appear on it. The moon slowly begins to divide into two parts. Both halves crumble into hundreds of large pieces. It's just falling apart. The Earth doesn't have a natural satellite anymore. It's just a pile of giant space rocks. But why is this happening? There's a space around our planet called the Roche limit. In this place, the gravity of Earth is stronger than that of the moon. This means that the forces holding the moon together are weaker than those that tear it apart. People are cheering. The Roche limit has saved the planet. The moon won't hit us. It breaks up into millions of fragments and forms a circle around our globe. Now, Earth looks like Saturn. A belt of moonstones surrounds us. Huge chunks destroy everything in their path, all the space debris. The satellites are no longer working. Humanity loses its means of communication and navigation. People will have to use paper maps again. The moon held our planet's orbit at a certain angle before these events. Now the axis is tilted differently. One hemisphere becomes closer to the sun, and the other plunges into shadow. The North Pole and the Arctic may turn into hot deserts, and the equator of the planet may be covered with ice. Winter and summer can last for years. The moon's remnants fly around Earth, but some of them fall on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the massive destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world.
As you know, all the planets in our solar system orbit the sun and bring a sense of order to the place. But guess what? There are two planets that could collide with each other and cause a cosmic catastrophe. Here's Neptune, the most faraway planet in our solar system. It's 17 times heavier and 4 times bigger than the Earth. It's 30 astronomical units from the Sun. 1 AU is the distance between the Sun and the Earth, so it's 30 times farther away from our star than we are. And Neptune makes a complete circle around the Sun in 164 years in an almost perfectly round orbit. Neptune is cold, calm, and stable. But there's one planet that can ruin this balance: Pluto. It's a dwarf planet covered in rocks and ice. It's 6 times lighter and 3 times smaller than the Moon. We're interested in its orbit. If you look at a map of the solar system from above, you can see that it's not round but elliptical, so it's a slightly flattened circle. At its furthest point, Pluto is 49 Earth-Sun distances away from the Sun. When it moves, it comes closer to the star. At its closest point, Pluto is about 29.5 AU from the Sun. That's closer than Neptune. So, hypothetically, they could collide. Let's look at this collision from the front row. A little closer, please. Good. Neptune and Pluto are slowly approaching each other. They are both very cold worlds, but they begin to interact with each other gravitationally. Just like two magnets, it warms them up from the inside. Neptune is a gas giant. There's no solid surface there, so there's not much change in it yet. But Pluto has a rocky surface. Because of Neptune's gravitational influence, it's starting to crack. Pluto experiences continuous earthquakes. This causes it to heat up even more. When Pluto almost touches the gas giant, it begins to crumble from the inside out. Plus, Neptune has a very dense atmosphere. So the dwarf planet begins to ignite from friction with the gases in the upper atmosphere. Pluto is now very hot on one side and very cold on the other. This causes severe deformation, and it begins to crumble. Half of the dwarf planet's fragments remain in Neptune's orbit. They will collide with each other until they turn into dust and become new rings of the big planet. Other fragments will burn up in Neptune's atmosphere. And the biggest rocks that remain of Pluto will fall through Neptune until they're completely burned into dust. Neptune literally ate Pluto and continued its orbit without any change, all because the gas giant is 20 times larger and much heavier than the dwarf planet. So this collision would do no harm to Pluto. But it couldn't have happened in the first place, because their orbits don't actually cross. Let's look at the map of the solar system again, not from above, but from the side. All 9 planets here are on a horizontal line from the Sun. The distance between them is great, and their orbits don't cross. Here's Pluto's orbit. You can see that it's tilted relative to the horizontal line of all the other planets. It starts at the top, then dives under the orbits of the planets and comes back. So Pluto can never collide with Neptune. Still, planetary collisions have occurred in our solar system before, and thanks to these collisions, life appeared on Earth. Let's go back in time to almost 4.5 billion years ago. This ball of hot lava is Earth. It just formed from a cloud of dust and began to cool. But then, a wandering planet the size of Mars appeared on the horizon. It's called Theia. It was inevitably approaching our planet. The collision with Theia happened at a perfect angle. If Theia had hit us head-on, both planets would have been smashed to pieces. But it hit us almost at a tangent. Theia knocked some of the matter out of the young Earth and crumbled into rubble itself. It could no longer continue its journey because the Earth caught it in a gravitational trap. A large fragment of this planet remained in our orbit. Smaller fragments crashed into each other, falling to Earth or joining the remains of Theia. The dust settled, and we can see the familiar picture, the Earth and the Moon. This is the main theory of how it came to be next to us. Scientists say that it was this collision that caused life to appear on Earth. Theia brought a lot of ice on it, which turned into water on our planet. The new moon stabilized Earth's rotation, and conditions on the planet became perfect for the emergence of life. Another collision could create a blast wave that would spread out thousands of light years. Stellar collision. This usually occurs in binary systems with a white dwarf and a regular star like our Sun. A white dwarf is the remains of a star that has gone out. As the stars get together, they start to move around each other in a spiral-like dance. The white dwarf pulls down the upper layers of the larger star. This hot plasma and stardust form a luminous disk. The two stars get closer and closer. When they finally merge, this causes a chain reaction in the core of the hot star. The massive matter presses on the star's core too hard. This causes the innards of the combined star to heat up even more, and it expands, creating a supernova. This is one of the brightest events in the universe. The light from the explosion can be seen hundreds of light years away. Another spectacular view is the collision of a star with a black hole. Black holes are the heaviest objects in the universe, and their gravity is incredibly strong. So when a star and a black hole get close, the black hole starts eating the lighter matter of the star. The hot plasma, like spaghetti, heads toward the heart of the black nothingness. For an observer, this plasma seems to settle on the very edge of the black hole. It's called the event horizon. The thing is that time is much slower near such a heavy object, so we think the matter stays on the event horizon, but in fact it's long gone into the heart of the black hole. As they get even closer, the black hole starts to literally tear the star apart and swallows it whole. At this point, the black hole spits out about half of the star's mass in the form of a beam of energy right out of its black heart. The other half of the star's mass becomes the black beast's food. We know of many black holes in our universe. The heaviest of them usually lies in the centers of galaxies. They can be millions of times heavier than the Sun. But what would happen if two black holes collided with each other? Our scientists had the opportunity to observe such an event. Two black holes weighing 66 and 85 solar masses gradually approached each other. They danced together, bending the light passing by them. But then they merged into one enormous black hole, weighing 142 solar masses. That same second, the new black hole released gravitational waves into space with an energy of 9 solar masses. Scientists were able to catch these waves and observe the merging of the two black holes from the front seat. But this event actually happened about 17 billion years ago. We're only now seeing it because the particles of light and gravitational waves took so long to travel the distance of 17 billion light-years to Earth. Now consider a galactic scale collision. Literally, it's a collision of the Milky Way and the Andromeda galaxy. This event will happen in 4.5 billion years, so stay tuned. The Milky Way has almost 100 billion stars. Andromeda has about 1 trillion. As the galaxies approach one another, they'll make several circles around each other. At that time, some stars may be ejected from the galaxies like from a slingshot. Then Milky Way and Andromeda will begin to merge. One scenario here is that our solar system will collide with another star system from Andromeda. In this case, there could be a stellar collision and a supernova afterwards. Our world would be destroyed. Another option is that the Sun would be ejected into dark space. In this case, we may not even notice the difference. All we'll see on Earth is a gradually disappearing starry sky, as our solar system will travel through dark space away from the home galaxy. But the most likely scenario is when the galaxies merge, it'll be completely painless for us. In fact, the space is very wide, and there's room for all the stars from both galaxies. The only difference is that we'll see a lot of new stars in the night sky, along with flying saucers from Andromeda. Nah, not really. But it's not the collision of galaxies that we should be worried about, it's our Sun. In 4.5 billion years, it'll become a red giant. It'll expand, swallowing up the nearest planets. Earth will probably be the first planet near the Sun. It'll be so hot that all life will simply disappear, and no one will be able to watch the galactic collision.
You're on a plane heading to an important astronomy convention when you see a large figure outside your window that eclipses the whole sun. You spit out all of your coffee, and everyone in the plane stares outside in shock. You then notice that it has rings like Saturn. You were supposed to fly to Japan, but you're forced to land in California. As soon as you land, you look up in the sky and see some more giant planet-like structures floating around in the sky. Everyone is taking pictures and trying to figure out what's going on. Suddenly, you notice a huge ball of fire crashing down near the airport. Everyone scrambles for safety, and luckily, it ends up in the middle of the runway with no one around. The bad news is, there's no more runway for planes to land. Everyone huddles together for safety, and more large objects appear in the sky. All communications have ceased or broken down since these large objects have ruined all the satellites. Some scientists nearby mention that these objects are the planets of the solar system going within the same proximity as our moon. Mercury and Venus look like moons, but Saturn is occupying a lot of sky real estate. You tell those scientists that you're an astronomer. They invite you to join them on a trip to Antarctica, to the observatory station in the South Pole. They need every mind to help solve this mystery. You get on a ship with the coordinates set to Antarctica. The waves are extremely rough for typical daylight and non-stormy weather. You finally make it to the shore of the continent after a few days and have to get in a snowmobile all the way to Amundsen Scott's South Pole Station. Over here, you and a group of scientists will figure out what's going on. You weren't prepared for the freezing temperatures, even though it's July. You arrive at the station and see all your fellow scientists running around with paperwork and blurting out stuff about planets orbiting our atmosphere. You arrive at the conference room where the lead scientist explains what's going on. One by one, the planets are coming closer to us until they're aligned with the moon, but they still don't know why and how. Venus arrived first, and now Saturn is getting closer. The moon is around 240,000 miles away from Earth, and it affects the tides of the oceans and seas with its gravitational pull. Since water is less dense than land, we can see the tides change. So high tides occur when the Earth is pulled towards the moon. And since the other planets are coming closer to Earth, the gravitational pull is erratically changing. In a couple of hours, Saturn will be in the same distance as our moon. You head to the large telescope and observe the planets. Any plane or helicopter won't fly properly and won't have the proper radar technology to help it. You keep observing and notice Mars getting closer to Earth. You get news that tidal waves are rising very often now, and some island nations are even being washed away. Good thing they got evacuated beforehand. With Mars closing in, you notice Neptune also getting closer. You can feel the gravity on Earth fluctuate with every step you take. You report your findings to the lead scientist, and the only way for survival is to quickly build bunkers far away from oceans and seas that can host many people before the other planets close in. A team of engineers arrive and start building. Wave after wave of survivors come and settle into the bunkers, practically built overnight. With every hour, more planets are getting closer. Mars and Neptune have already settled in, with Mercury, Venus, and Saturn. Pluto and Uranus are now visible to the unaided eye and are making their way towards Earth. The gravitational pull is getting completely out of hand. The snow in the Antarctic desert remains floating for several seconds whenever someone walks on it. You can jump a lot higher. It's now nighttime, but the sky isn't dark as usual. The planets are reflecting a lot more sunlight than our moon. It's barely visible now. With more observations, you notice comets and meteorites flying very close to our atmosphere. Some are even crashing down on Mars and Neptune. Everyone can see it from Earth. Other space debris also finds its way into Earth's atmosphere. But you notice something strange. The planets are now orbiting Saturn. You check your calculations and find out that the planet's positions are now aligned with Saturn's orbit. That's because it has the biggest mass among all the planets. Saturn's rings are made up of ice particles, some as large as a bus and others as tiny as pebbles, but they're all crashing and interfering with the other planets. No one can feel the orbit shift at first, but later you can start to feel it. With this happening, earthquakes and volcanoes are bound to happen. This is why everyone, including yourself, is packing up and ready to flee. Antarctica has dozens of volcanoes hidden beneath the frozen ice. Some are underground, while some are right on top. Saturn's gravitational pull is much stronger than Earth's gravitational pull on the moon. This will cause the inner core to react a lot more and kickstart those earthquakes and volcano eruptions. Everyone packs up super quick and heads to the choppers to fly to South Africa. These choppers were designed to have a direct course without the need for radars to guide them. You arrive in South Africa, which is mainly covered in water. The chopper takes you closer to the center, and then you travel to the Sahara Desert. The plain surface with nothing around it will be the best option for safety. But you look up in the sky and see another planet closing in. It's Jupiter, the biggest planet in our solar system. If Earth were the size of a grape, then Jupiter would be the size of a basketball. It's approaching quickly. Many of the other planets automatically make way for it, including Saturn. You're on the road heading to the Sahara, even though it'll take days to reach by car. The sky is dark during the day, since most planets are blocking the sun. You finally make it to the Sahara Desert with other scientists, and to your surprise, a whole city was erected in just a month when the planets started showing up. You settle in your dorm, but still have a lot of work to do. A couple of days later, Jupiter breaches the atmosphere and completely eclipses us. But Earth is now rotating around it, and it's much quicker than orbiting the Sun, since Jupiter is smaller. But since Saturn is also big, Earth keeps getting tossed from orbit to orbit, like two people playing a ball game with each other. So with that happening, people on Earth are experiencing different gravitational pulls from time to time. The tidal waves keep getting stronger, and volcanoes are erupting everywhere. Since the Earth's core is getting hotter, the temperature on Earth is also changing. And with a lack of sunlight most of the time, much of the plant life is having a hard time trying to keep up. Crops are harder to plant with natural sunlight, so people are turning to artificial lighting and greenhouses. Air and space travel are impossible. The International Space Station is completely ruined, along with the satellites orbiting space. That's why cell phones and the internet can't work. Gravity is even more dysfunctional than ever. 6 months later, humanity has found some way of coping with the new normal, but things are constantly being updated. The number of hours in a day has changed, as well as days that compose a week. This used to be measured with the moon phases. A month used to be the moon achieving all phases from none to full moon, and so on. But Earth's moon has disappeared with the cluttered, disorganized planets.
There's this mysterious thing in space, an unusual spot that scientists haven't been able to explain for more than 15 years. There are different theories, and one of them says that maybe this is an imprint from a collision with a parallel universe. Is this true? Well, let's see. Take a look at this map. This is the map of our universe. Well, not really. This is actually the map of cosmic microwave background radiation, or simply CMB. Many billions of years ago, there was a Big Bang. It was so powerful that it created our entire universe. And, of course, such an event couldn't occur without leaving some consequences. And these consequences are literally everywhere. The Big Bang left electromagnetic radiation, which we know as CMB. We don't notice it in our daily lives, but it's literally here, under our noses. And if you had some kind of superhuman vision, you would see how everything around you shines with this dim light. This radiation is very important. If we hadn't discovered the CMB, we would never have found out about the Big Bang. Previously, scientists believed that the universe had always existed. There was no beginning and there was no end. It sounded pretty ridiculous to us now, but less than a century ago, people were absolutely sure of it. Stephen Hawking was one of the first scientists to guess that the universe did, in fact, have a beginning. The guy was so cool that he realized this as a student while working on his doctoral dissertation. But unfortunately, he had no proof. If there was such a strong bang billions of years ago, then where are the traces? Where's the proof? Laughed people who believed in the eternal static universe theory. But don't worry, they had the proof rubbed in their faces real soon. In 1965, astronomers Arno Pienzas and Robert Wilson discovered CMB, and that was the first grandiose proof of the Big Bang. It turned out that radiation was everywhere. We just didn't notice it. In fact, at first, Pienzas and Wilson themselves mistook it for the noise of a big city, or pigeons, or something else. For their discovery, which turned the world of science upside down, they received the Nobel Prize. Alright, so people learned that they were surrounded by electromagnetic radiation. Then they started collecting more data about it. They accumulated more and more info over the years until they made this very map. This is a map of CMB temperatures. But while creating it, scientists discovered something unusual. Let's take a look at this map. It looks like a large and diverse pattern of cold and warm places. But in reality, our universe is quite uniform. All temperatures on this map are close to negative 455 degrees Fahrenheit with very little difference. All temperature fluctuations between these places are small, and each tiny speck actually spreads over millions of light years. So everything in our world is pretty calm and stable, except for one point. This cold spot right here. Astronomers first discovered it in 2004. First, it looked like nothing unusual. It's just a region where the temperature is below average for a couple of microkelvins. But remember, we're not talking about a small area. This is a giant cold region. It's literally billions of light years in size. Wait, the scientists thought, this can't be true. The universe should be consistent everywhere. According to our standard model, this cold spot simply shouldn't exist. But it does exist though. This isn't just some mathematical error, it's right there. So what is this cold spot, and how did it appear? Astronomers have been trying to find the answers to these questions for years. Even now, we have only a few theories. So let's discuss them all. Theory 1. Cosmic texture. This idea was brought up at the end of 2007. Then scientists suggested that this cold spot could be the hills of space. In other words, it may be a bumpy region of the universe, just part of its texture. But that's a silly explanation, so this theory was quickly discarded. Theory 2. The supervoid. This hypothesis was considered the most plausible for a while. It stated that the cold spot was actually the so-called supervoid. It's a terrifying, dark place of our universe with almost no galaxies. And because it's an empty region with almost no stuff in there, it seems cold to us. However, this theory was refuted in May 2017. After carefully examining the cold spot, scientists found out that there were no signs of a supervoid there. Moreover, voids and supervoids, which actually exist by the way, are still very small in size. The cold spot is literally thousands of times bigger than them, so there must be some other explanation. And there is one, perhaps the most bizarre of them all. Theory 3. A parallel universe. This controversial idea was put forward by cosmologist and theoretical physicist Laura Mersini-Houghton. She suggested that the cold spot could be an imprint from the collision of our universe with a parallel one. Standard cosmology cannot explain such a giant cosmic hole, says Mersini-Houghton. This is the unmistakable imprint of another universe beyond the edge of our own. Her assumption is based on the theory of the multiverse. This theory says that there's actually an infinite number of universes like ours in the world. They constantly collide with each other, giving each other a push which creates a new Big Bang. So maybe the cold spot is a bruise from such a collision. For quantum mechanics, such crazy theories are pretty common, but for standard physics and our simple understanding of the world, this is earth-shattering. Of course, we need strong evidence. And Mersini-Houghton's team has begun to work on it. Professor Tom Shanks from the Center for Extragalactic Astronomy at Durham University also participates in this research. The craziest sounding of the exotic models for the explanation of the cold spot, the multiverse is actually the most standard in terms of our current model of the universe, he wrote in one of his works. So, what evidence do we need? Well, our cold spot is located in the southern hemisphere. According to Shanks, if there really was a collision between two universes, we should find another cold spot, and it should be in the opposite northern hemisphere. If astronomers actually found it, this theory would be confirmed, and it'd become the first proof of the existence of a parallel universe. But it's not that easy. To find a second spot, we need the latest, highly sensitive telescopes. We also need to find out some info about the nature of dark energy, how it affects space, and, in other words, there's still a lot of work to do. Not so long ago, scientists actually believed they had discovered the second spot. Researchers from New Mexico thought they had found it in the northern hemisphere. But unfortunately, this is likely to be a mistake. The map these researchers used had a high measure of randomness, so it's possible that their discovery is just an accident caused by other voids. So basically, we haven't found another cold spot so far despite careful analysis. But again, even the best modern equipment is not perfect, and it doesn't mean that there's no second spot. It just means that we haven't found it yet. But if one day we did find it, it could change the world of science forever. We'd confirm not only the theory of parallel universes, but also the famous string theory. It could explain everything that occurs in our world. But if this happens, we'll get even more questions than we already have. How did these two universes collide? How does it all work? So far, it's all just guesswork. We can't claim that the cold spot is a print from the collision of parallel universes. But we can't refute this either. Actually, we may never know the truth at all. But it's still interesting to strive for it.
This explosion is the brightest and most powerful in the history of our entire universe. And it was the start of absolutely everything. a big bang that happened 13.8 billion years ago. Elementary particles began to spread out in different directions and cool down into matter. This is the building material for the future universe. All the galaxies, black holes, stars, planets, asteroids, and even you and me. Yes, we're all created from the same set of particles that appeared at the Big Bang. A quick jump to 4.6 billion years ago. This is the nebula that's about to become our solar system. It's just a cloud of cosmic dust, rocks, and blocks of ice. Shock waves from supernovas from different directions around this place begin to push matter into a common center, just like sea waves. At one moment, all this matter begins to shrink around a center of gravity into one giant boulder. It attracts more and more other debris to itself. It presses on its own center so hard that nuclear reactions start there. A little more pressure and let there be light. And that's how our sun was born. 4.59 million years ago. This is when the first gas giant planets, Jupiter, Saturn, Uranus, and Neptune, are formed. They're composed entirely of gas and have no solid surface. Some say there was a fifth gas giant, but it was ejected outside the solar system. For another 100 million years, there's a solar nebula, a bright young star in the center, and a disc-shaped pile of gas and dust around it. These are remnants of matter from the original nebula. It's more like a boiling soup. The ingredients swirl around the sun, stirring and colliding with each other. They form the rest of the planets and moons of our solar system. When the dust settles, we can see Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, Saturn, Uranus, and Neptune. 4.5 billion years ago. While Earth is still a red-hot lump of rock and lava, Theia appears on the horizon. It's a protoplanet the size of Mars. It's formed close to Earth and is now flying toward it. Theia shatters into pieces and rips out a large chunk of our planet. A lot of debris is left in Earth's orbit and begins to come together. This is how the Moon was born. 4.1 to 3.8 billion years ago. This is the late heavy bombardment period. The remnants of debris that didn't become planets continue to travel through the solar system. They hit the gravitational fields of the freshly born planets and fall on them. Because of this event, we can see so many craters on Mercury and the Moon. Scientists have found the remnants of the oldest microorganisms in the world. They're about 3.8 billion years old. So, they were born around the time when the chaos of ever-falling meteorites ended. The process of evolution began. 3 billion years ago, strong solar winds and frequent meteorite impacts on Mars deprived it of its atmosphere. The atmosphere protected Mars from solar radiation, and now life can't be born there, although some scientists say that Mars was once inhabited. 2.5 billion years ago, an oxygen disaster is happening on Earth. Some organisms evolved to feed on the sun's energy and produce oxygen. Our atmosphere began to fill with it, and this washed away almost all pre-existing life forms. But it did pave the way for new ones. 100 million years ago, one of Saturn's moons was destroyed, either by a collision with a large asteroid or by the planet itself. The moon's debris began rapidly orbiting the planet and colliding with each other and turning into small rocks and dust. Most of this debris consisted of ice, and they remain to circle Saturn to this day. You can see it as rings near the planet. 66 million years ago, Earth suffers the impact of an asteroid the size of Manhattan. The blast waves from the impact can be seen from space. The ash cloud then completely covered the Earth and blocked the sun's rays. As a result of this event, most living organisms, including dinosaurs, ceased to exist. 70,000 years ago, let's look at the edge of the solar system. There's an area of asteroids and blocks of ice, the Oort cloud. And there's a rogue double star system approaching it. It pulls the asteroids out of the Oort cloud and throws them in our direction like a slingshot. Fortunately, the star passed by the solar system, but promised to return. 356 years ago. This is the date of the first discovery of the Great Red Spot on Jupiter. It's the source of strong winds on the planet, with speeds like the fastest supercars. If you compare this spot to the planet Earth, the spot is 30% bigger. Present time. The solar system looks exactly the same now as it did a few billion years ago. But humanity has added some new objects. You can see many artificial satellites and a vast international space station. Even on Mars, there are several rovers we sent there. Now let's look to the future. In the next few decades, Earth will constantly send spaceships to Mars. Every 2 years, when the distance between the planets is shortest, you may see an entire fleet of ships speeding toward the red planet. 100,000 years from now, the rogue star returns to the solar system. It disturbs the Oort cloud again and flies away. In 9 million years, it'll approach a record close distance of 52,000 Earth-Sun distances. 10 million years from now, Mars's moon, Phobos, has been steadily approaching the planet by 6 feet every 100 years. Gravitational interaction will first tear it apart. Some of the debris will fall on the red planet. Others will remain in its orbit in the shape of rings, just like Saturn's. The future of the solar system depends entirely on the Sun. Every 1.1 billion years, its luminosity increases by 10%. This is because, over time, it'll burn more and more hydrogen fuel and get hotter. 1 billion years from now, Earth's temperature will become so high that liquid water will no longer exist. The oceans will evaporate, creating a greenhouse effect that will heat up the Earth even more. The existence of life here will become impossible. At this point, we see an entire fleet of ships flying toward Mars. These were the last inhabitants of Earth. As a result of the Sun's increasing brightness and temperature, its habitable zone, that sweet spot for life in the solar system, has moved farther away from the star. Mars is now much warmer. The ice beneath its soil became liquid and evaporated, creating a greenhouse effect. Now the conditions on Mars are perfect for humans. 3.5 billion years from now, Earth now looks like modern-day Venus. It's filled with lifeless landscapes, with volcanoes and dry riverbeds. 7.7 billion years from now, the Sun's hot core triggers nuclear reactions in the outer shell. As a result, the Sun begins to expand and becomes a red giant. The star will increase 256 times in size. It'll literally swallow the nearby planets, Mercury and Venus. While the Sun is insanely burning fuel, it's losing weight, and its gravity is weakening. This means that it no longer holds all the planets together as much, and their orbits expand slightly. So there's a chance that Earth will remain intact and will now be the first planet near the Sun. Mars has gotten too hot for humans too, and we're making another distant migration, this time to Saturn's satellite, Titan. This is the only place in our solar system where water in liquid form has been proven to exist besides Earth. Conditions here should now be suitable to welcome humanity home. When the Sun uses up a little more than half its fuel, it'll begin to shrink to a size 11 times larger than today. But in another 100 million years, it'll become a red giant again for the last time. After that, in another 30 million years, the star will begin to eject strong solar winds and stellar matter. There will now be a beautiful planetary nebula, which consists of the former outer shell of the Sun. The star will lose most of its weight, which means it'll no longer be able to hold the orbits of the planets. Chaos begins in the solar system. Some planets leave the borders of our world. Others collide with each other. But some of them will be able to stay here, but in a more distant orbit. And in 75,000 years, only a white dwarf the size of the planet Earth will remain in the center of the solar system. The Sun will gradually cool until it fades away completely. If there are still planets left, they will be cold and dark, incapable of supporting any form of life. From its birth to the end, the entire history of the Sun will take about 12.4 billion years.
Uh-oh. Something is nearing the surface of the planet. It looks like a fireball, hurtling closer and closer at a truly incredible speed. Soon, it becomes obvious that the collision is inevitable. Bam! The impact leaves a huge crater. It evaporates thousands of cubic miles of solid rock, and it also sets off a series of terrible natural disasters. I know what you're thinking. You believe I'm talking about the catastrophic collision that occurred around 66 million years ago on Earth. You know, the one that's responsible for the extinction of non-avian dinosaurs and 3/4 of other life forms on our planet? But no, The disaster I'm talking about happened on a different planet. Scientists think that our close neighbor, Mars, once experienced the same catastrophe that struck Earth. It happened around 3.4 billion years ago. An asteroid collision might have caused a mega tsunami on the red planet, similar to the one that caused the Chicxulub impact on Earth. Scientists have identified an impact crater on Mars that was probably left by a comet or asteroid collision with the surface of the planet. Most likely, the space body landed in an ocean in the Martian northern lowlands, and the impact was so powerful that it caused a mega tsunami. Before the latest studies, the exact location of the impact crater wasn't verified. It was just a theory. To confirm it, a team of astronomers simulated a comet and asteroid collision in the area where they supposed the impact crater was. They even named this crater Hall. Hall is 68 miles across and lies in a region that is almost 400 feet below the supposed sea level. Anyway, the simulations formed several craters of the same size as Paul. One of the simulations claimed that these craters had been left by a 5-mile-wide asteroid that had encountered strong ground resistance. The other simulation showed that the craters had been caused by a bit smaller asteroid that met a weaker ground resistance. But, according to both simulations, the impact crater was almost 70 miles in diameter, and the collisions produced mega tsunamis up to 900 miles away from the center of the impact site. The simulations also helped scientists estimate the height of the tsunami. It was about 820 feet tall, almost as tall as the Eiffel Tower. The authors of the study also suggest that the Pole crater might be similar to the Chicxulub impact crater on our planet. The Chicxulub asteroid, as we now know it, is believed to come from the outer reaches of the solar system. This space body was at least 6 miles across. It crashed into the shallow seawaters near the Yucatan Peninsula. This splashdown was so powerful that it left its signature on the entire face of the planet. In 2021, researchers found out that the collision had carved mega ripples into Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists remodeled the events of the first 10 minutes after the impact, and the model showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. That's like 2 Burj Khalifas, which is the tallest construction in the world, stacked one on top of the other. And of course, all that empty space didn't stay empty for long. The ocean gushed back to fill the crater. But in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. Imagine a 3-story building rushing up to you. No wonder the largest and fastest moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall, which is taller than the Statue of Liberty, and moved at a speed 10 times greater than more distant tsunami waves. But back to the red planet. Some experts think that not 1 but 2 mega tsunamis could happen on Mars. They could be triggered by a pair of meteor impacts that were several millions of years apart. Between these 2 collisions, Mars went through a period of climate changes. As a result, liquid water on its surface turned into ice. In other words, the first asteroid impact most likely produced waves composed of liquid water, and the second tsunami was probably formed by rounded chunks of ice water. By the way, the largest asteroid to have ever crashed into Earth might not actually be the one that ended dinosaurs. A much more catastrophic collision likely happened about 3.5 billion years ago. New evidence scientists found in northwestern Australia suggests that the asteroid I'm talking about was 12 to 18 miles across. It struck Earth at an immense speed, releasing an unimaginable amount of energy. Now, this made me think, what if something like that happened these days? More than 30,000 objects that are circling Earth these days could potentially crash into our planet. NASA considers around 1,500 of them to be potentially hazardous. These space rocks are the remains left after the solar system was formed some 4.6 billion years ago. For example, in 2004, astronomers discovered a huge asteroid nearing Earth. The first observation showed that the chance of the space rock hitting our planet was less than 3%. The asteroid was named Apophis. It's more than 1,200 feet across and weighs about 20 million tons. It's supposed to streak across the sky on April 13, 2029. Apophis will pass at a distance of 19,000 miles away from Earth's surface. But even though this space rock might miss our planet in 2029, it doesn't mean it won't return 15 years later in 2036. If such an object hits our planet, the consequences will be unpredictable. They can vary from shattered glass and broken windows to most life forms getting wiped off the face of the Earth. And it'll probably affect the internet. Now that last thought is truly scary. But luckily, modern technologies are likely to help us avoid any catastrophic consequences. Experts have developed several ways to prevent a real-life disaster movie from happening. For one thing, we could use a spacecraft to knock this visitor from outer space off its course. Or it could somehow be blasted into pieces. Scientists could also slow the thing down with the help of concentrated sunlight. Or people could tug it away with a gravity tractor. That's a theoretical spacecraft that can influence objects in space without touching them. In sci-fi movies, a huge asteroid often sneaks up on Earth and turns out to be a nasty surprise to astronomers. It hurtles toward our planet at breakneck speed and gets discovered just weeks or even days before the collision. In reality, scientists are constantly watching all large objects in Earth's neighborhood. It means there would be plenty of time to do something before the inevitable happened. There are 3 kinds of missions scientists could prepare at short notice. Type 0, when a heavy spacecraft hurtles toward the intruder with one single goal: to knock it off its course. In this case, astronomers would have to rely on the already available information. The Type 1 mission would involve a scout. It would be launched first to get more close-up information about the space rock. Only after that, the main spacecraft would be launched. With more precise information, its journey would be way more productive. And if scientists chose the Type 2 mission, they would send a scout and a small spacecraft at the same time. The spacecraft would knock the asteroid a bit off its course. Then the scout would collect all the necessary information. Based on this data, the spacecraft would finish its job with a more fine-tuned second push. If none of these methods work, people could try going deep underground or even build a shelter on the ocean floor. But in this case, we'd need to find sources of energy that could help us survive for at least several decades. Plus, people would have to create a life support system that could somehow keep air and water fresh. What a nice cosmic family. Meet Mars. I bet you've met him before. These 2 little guys are Phobos and Deimos, Mars's small moons. But it seems like Mars isn't treating the little ones the right way. Phobos and Deimos are believed to be captured asteroids. However, Phobos is gradually moving closer to Mars due to gravity, and it is predicted that it will eventually be destroyed by the planet's gravity within the next 35 million years. I won't be around then. So, I imagine this will result in a ring of debris around Mars, similar to Saturn's rings. However, this process is a natural phenomenon and not an act of destruction by Mars. Apparently, Phobos is getting ripped apart by the crazy gravitational forces of the red planet. But wait, there's more! Phobos has these crazy parallel grooves all over its surface. We used to think that they were from an asteroid crash, but now scientists think they're actually from Mars's intense gravity pulling the moon apart. Talk about a rough ride. Scientists have this wild idea that when a little guy like Phobos gets too close to a big guy like Mars, it starts to stretch out towards it. They call it the tidal force. Phobos is predicted to get stretched out so much that it'll actually break apart. Crazy, right? And the debris from the moon will form a tiny ring around Mars, just like Saturn's rings. Now, some people thought that Phobos' tiger stripes were caused by tidal forces before, but that theory got shut down because the moon is just too darn fluffy. But now, these genius researchers ran some computer simulations and found out that maybe there's a hard shell underneath all that fluff that could create grooves on the surface. But don't worry. At the rate Phobos is going, it's going to crash into Mars in about 40 million years. But if tidal forces are already tearing it apart, it might not even last that long. However, we'll still have the chance to learn more about Phobos. NASA just picked 10 rockstar researchers from all over the U.S. to join the science working team for JAXA's Martian Moons Exploration, or just MMX mission. As NASA-supported participating scientists, they'll be helping JAXA explore the 2 Martian moons, Phobos and Deimos. And get this, they're even planning to land on Phobos and grab a surface sample. The mission is set to launch in 2024, and we'll get our hands on that sample in 2029. 7 of the lucky researchers will be using the MMX flight instruments to conduct their research. Phobos is a real oddball. It's only 17 miles wide and orbits Mars at a distance of 3,728 miles, to be precise. Now that's way closer than Earth's moon, which takes a whole 27 days to orbit us. But Phobos is in a death spiral toward Mars and is slowly falling towards the planet's surface at a rate of 6 feet every 100 years. But there must be a reason why Mars is acting that nastily, right? What if it's all just because of plain vengeance? Well, okay, picture this. Mars is minding its own business, being all hot and watery like a young Earth. It's got a sweet magnetic field that's protecting it from cosmic radiation and keeping its atmosphere nice and thick. Hey, life is good. But then, at least 20 asteroids, each the size of a small country, come crashing down on Mars like a giant game of cosmic whack-a-mole. One of them even leaves a crater that's almost 2,000 miles wide. Now imagine how Mars must feel with 2 asteroids being its moons after what other asteroids did to the red planet. All these impacts are like a massive punch to Mars's gut, and its already weak magnetic field is knocked out cold. The core gets all overheated and can't circulate properly, which means no more magnetic field to protect the planet. It's like as if you were wearing nothing at the depth of the Mariana Trench. If it were possible, you'd be defenseless and chilly. It's basically what happened to Mars. So now, poor Mars is out there in the cold, unprotected from all those nasty cosmic rays. It's like going outside without sunscreen, not a good idea. But at least we can learn from Mars's mistakes and make sure Earth doesn't have the same fate. Maybe we should start investing in some asteroid insurance. But trust me, the red planet isn't mean at all. It's actually pretty friendly. While Mars may seem to be pretty tough for Phobos, there's something that might be thriving with Mars's help. So get this, a team of scientists found a way to grow rice on Mars. Yep, you heard me right. They used MMS, not the outdated way to send pictures, but a special soil called Mojave Mars Simulant. It's supposed to mimic Martian soil. And here's the catch, Martian soil has these nasty percolate salts that can be toxic for plants. So the team grew 3 types of rice, 1 normal and 2 gene-edited with mutations that make them better at handling stress like drought or salinity. And guess what? The mutant strains were able to root in soil with 1 gram of percolate per kilometer. Take that, Martian soil. But hold up. The rice grown in the MMS didn't turn out as great as the ones grown in regular potting soil. So the team decided to mix a quarter of the potting soil with the Martian simulant, and looky there, the plants started developing better. Now these scientists aren't just thinking about feeding Martians. They also want to see if their findings can help grow crops in places on Earth with high salinity. And get this, the whole project started when 2 researchers met for coffee and decided to try growing plants together. Well, isn't that nice? I suspect you're about to say, hey, but if you want to grow rice on Mars, you'll have to ship insane amounts of water from Earth, and it's not easy to quench this plant's thirst. You're right. You need about 449 gallons of water to only grow a pound of rice. But guess what? Scientists made a groundbreaking announcement at the Lunar and Planetary Science Conference in Texas. They found a relic glacier near Mars's equator. That's right, water ice on Mars, even near the equator. This is huge news, and could mean there's even more ice just below the surface. It's not just any glacier, it's a relic glacier that's estimated to be 3.5 miles long and up to 2.5 miles wide. It's like the size of a small town. It's got all the features of a glacier, including crevasse fields and moraine bands. But get this, it's not actually ice. It's a salt deposit that formed on top of the glacier while preserving its shape. So, how did this salt deposit form? Well, it turns out that volcanic materials blanketing the region might have something to do with it. When these materials come into contact with water ice, sulfate salts may form and build up into a hardened, crusty layer. Over time, erosion removed the volcanic materials, exposing the sulfates and revealing the glacier's unique features. This glacier is young, likely from the Amazonian geologic period. That means that Mars has had surface ice in recent times. Who knows what other icy secrets Mars is hiding? But hold your horses, there's still more research to be done. Scientists need to figure out if there's still water ice preserved underneath the salt deposit, or if it has disappeared entirely. And if there is still water ice at shallow depths near the equator, that could have major implications for human exploration. Imagine being able to extract water from the ground at a warmer location. That would be a game changer. So let's see what else these scientists uncover about our favorite red neighbor. Maybe someday we'll even get to visit that salt glacier statue in person. See you next time. Earth. The third rock from the Sun. The blue planet. You get it. Its atmosphere is made up of around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide. A nice balance for any living creatures to breathe. The weather here is also perfect for life to exist, unlike places like Saturn, Mercury, or any other celestial object in our solar system. We have the troposphere to thank for that. It's the densest part of the atmosphere on our planet and is 5 to 9 miles wide. It's the layer of the atmosphere that always affects our weather and secures the right conditions for life to exist and to have bodies of water. Earth is just sitting in its orbital path, minding its own business, revolving around the Sun until, BAM! Venus and Mars swoop in and spoil the fun. No one wants to leave poor Earth alone. These two relatively large celestial objects moving toward Earth will have dire consequences for our planet, starting with changes in its orbiting trajectory path. The planet's orbits in the solar system have to maintain the right balance so that nothing goes haywire. Of course, if any large object approaches Earth, it would throw our orbiting path off course. The planets will revolve around each other, which will cause plenty of natural disasters on our lands. This will also affect our rotation timing, potentially slowing it down. Days will not flow but drag by. Animals that rely on daytime will need to readjust their biological clocks. Nocturnal animals will also need to figure out how to cope with the long nights. Humans have adjusted pretty well to the 24 hours a day timing. Time itself is just a human construct to measure things. We'll have a tough time sleeping and adjusting to the stretched day. Marine animals rely on the natural current flow to migrate around the oceans. With Mars and Venus crashing the party, it looks like they will also need to find new paths. Birds migrating to other lands throughout the year will also be confused and not know what to do. In general, the Earth's temperature will rise, and massive heat waves and permanent climate changes will occur. This brings us to our next issue, the heat. The radical temperature rise will turn everything into a barren desert. It'll be summer all year long, especially if Venus is in the picture. Most of the planet will dry up and won't be suitable for growing crops. Venus is hot, really hot. Even though it's not the closest planet to the Sun, it's still the hottest. The temperatures on Venus are close to 900 degrees Fahrenheit, which will melt you like an ice cube. The lands on Venus are generally flat, probably due to the temperatures. It's mainly hot because its atmosphere is thick and traps the hazardous gases inside. If Venus inches its way towards us, it'll invite those gases to our atmosphere and compromise it. Mars, or the red planet as we know it, is very cold. That might stay the same if it starts rotating around us. It's also home to the largest dormant volcano in our solar system, which makes Mount Everest look like a tiny bush compared to a tree. With so much instability, it might just wake up one day and spew out molten lava. Mars has a very thin atmosphere, which makes the planet chilly. Its gravity is quite similar to ours. It's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and sunset. The three planets orbiting each other will eventually collide. It's just a matter of time. And the Moon, just hanging out like a fly on the wall, will be so insignificant that something will eventually throw it off course and another planet will capture it to its orbit. Or, in the most dire case, it will collide with one of the two intruding planets. Earth will experience extreme tidal waves like nothing before. The two new planets revolving around Earth will cause a major imbalance, making our gravity shift out of control. Each tidal wave will be bigger than the previous one and will cover the dry land. Plenty of little scattered islands in the oceans will be completely submerged. Coastal cities and towns will also be home to fish. Flat countries in general will need boats to get around. Dams and dikes won't be enough to stop the water from coming in. Everyone needs to move towards higher ground to escape the floods. With the climate getting hotter, the polar caps will melt like ice cream on a sweltering summer day and add to the water level rising. Within a few months, the whole Arctic will be nothing but liquid. But wait, there's more! The crust will wear out due to the instability of the Earth's surface and fluctuating gravity. The Earth's crust is mainly made up of oxygen, which means we're basically walking on air. We might experience more earthquakes than before, and dormant volcanoes will wake up from their deep slumber. The skies will be covered in ash, making flights impossible. No one can travel by sea or by air. Importing and exporting will become history. The overall climate will get hotter, just like in Venus. The three planets orbiting each other and their huge mass might even unintentionally welcome other planets and celestial bodies to join the party. So, what if Jupiter decided to turn up? Now, Jupiter is the largest planet in our solar system. To give you an idea, the Earth would be just the size of a grape if Jupiter were the size of a basketball. It also has the largest storm we can perceive. That's known as the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. Now, by the time you're done watching this video, you can expect the storm to still be going at it. Since the planet is huge, gravity must be quite strong here. It also has many moons, some of them of our little Earth. There will be no room for any proper space among the planets. Jupiter's moons will be thrown off course and latch onto other planets around. Some of the moons might collide with each other, causing massive debris to be displaced all over the place. The gravity of the planetary party will attract comets to enter the atmosphere, potentially crashing down on us. Oxygen levels will deplete, so the Earth's crust crumbling will continue. It'll rip open the ozone layer, causing heavy strokes of ultraviolet waves to enter our atmosphere. We won't be able to step outside for too long without some protective gear and oxygen tanks. Human civilization will change drastically. We'll all live in sheltered containers that will provide clean air and safe and filtered sun rays. The shelters will be sturdy enough to withstand frequent earthquakes. We will grow only enough crops to sustain ourselves until we leave the Earth. Since it'll only be a matter of time before the planets collide, the next step would be to create large rocket ships to fly us out of the Earth. With Mars, Venus, and Jupiter revolving close to us, it won't be easy to do so. All the space debris will be blocking us from exiting the space zone area. The only safe place outside this region will be many millions of miles away, where only single planets exist. They may or may not have the conditions to host life, but humans will have the technology to land just about anywhere with similar gravity and construct the right shelters. Eventually, Mars, Venus, Earth, and Jupiter will collide with each other and break like eggs, like a big space omelet. Don't forget the moon's crashing and breaking in the mix, but we'll already be far, far away by then, hopefully. electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far, though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our Sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These two phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under 2 continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the moon is so dry and doesn't have much of an iron core. But why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington event, which happened way back in September 1859. It gave us a sneak peek of what the power of the Sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the Sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed 2 enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges. Bang! Another hit on Jupiter. Let's see. Gas giant, the largest planet in the solar system, 318 times bigger than the Earth, 2.5 times bigger than the rest of the planets in the solar system put together. One more interesting thing. If it got any bigger, it would actually become smaller. You see, with more mass, the planet would be denser. That would cause Jupiter to start pulling in on itself. Scientists say Jupiter could have 4 times greater mass, but still keep the same size. It takes 10 hours to make a full rotation on its axis. It's the fastest spinning planet in our solar system and gets hit by so many space objects all the time. This was discovered by amateur astronomers observing Jupiter and saw some unusual flash at the planet's surface. Impact events cause flashes like that, and for some reason, Jupiter gets more impacts than other planets. In 1994, astronomers discovered Shoemaker-Levy 9, a comet that broke apart and collided with the gas giant. The original comet was approximately the size of one that erased the dinosaurs. However, this asteroid fell apart into more than 20 fragments. They darkened the planet's surface, and it remained like that for months. 15 years later, in 2009, astronomers saw a black spot on Jupiter, the size of Earth. It was the result of an asteroid around 650 to 1,650 feet in length. The biggest asteroid recorded on Earth hit the area of Tunguska, Russia in 1908. This caused a massive explosion, even though no one ever found a crater. So, why is Jupiter the target for so many space objects? Asteroids and comets that pass by Earth and Jupiter go almost at the same speed. The number density of the space object that may interact is almost the same too. But the cross-section of what they might hit is very different. Jupiter has 11 times the diameter of our planet, which means it has around 125 times the cross-section. The more massive some planet is, the stronger its gravitational attraction. So, it will entice some space objects drifting by. Our gravitational field is weaker than Jupiter's. If some object passes near us moving at a speed of 22,300 miles per hour or less, our gravitation will attract it. Asteroids and comets usually move at bigger speeds. Jupiter attracts most of the comets and asteroids passing by. If our planet was hit by such big objects as frequently as Jupiter, we'd have extinction like with dinosaurs thousands of times more often. In 2020, scientists found there was an unusual asteroid in the orbit of Venus, the first one there. The size of a small mountain and rich in minerals we can find in Earth's deep rocks. They even think it could be a clue to a bigger set of asteroids created when our solar system was forming. That's not the only mystery around Venus. The planet has insanely violent winds that drive clouds and storms around the planet at speeds greater than 220 miles per hour. That's 60 times faster than Venus itself rotates. Also, scientists are still not sure what happened with its oceans. They believe since the planet is so close to the sun, the water evaporated and went into the atmosphere as steam. It trapped heat coming from the sun, heat that would have vaporized more and more water over time. Venus probably had an environment like on Earth, but a very long time ago. The theory says many comets and asteroids were slamming into Venus. Billions of the planet's pieces were flying all around. Some may have even crashed into Earth's moon. Pieces that slammed into our planet are probably buried very deep, since we have greater geological activity than the moon. Uranus also had a collision, but a more serious one than asteroids. The rest of the planets in our solar system mostly have an axis of rotation that kind of points up from the elliptical plane. Uranus is tilted, lying on the side, so a season there lasts 42 years, when either its south or the North Pole is pointed at the sun. Most of the planets also rotate counterclockwise when you see them from above our solar system. Venus does the opposite, which means maybe it was kicked off axis a long time ago. Uranus may have collided with the other space body millions of years ago. When our solar system was still very young, the orbital configuration of Saturn and Jupiter may have crossed. Their gravitational forces kind of created orbital momentum and transferred it to Uranus. That knocked it off axis. Millions of asteroids orbit the Sun, and not so many pass by Earth from time to time, so we don't have some dangerous space bodies coming toward us. The plan is to visit Mars in the 2030s, and scientists hope Mars won't be a target of some bigger space bodies. New craters are formed on the red planet every 1 to 2 days. They can be 13 feet across, which means they could have been formed by objects that are the size of a soccer ball. Since the atmosphere there is thinner than ours, smaller bodies can enter easier. Most of the Martian north is smooth lowlands. The south is higher, full of craters, and the planet's interior has a surprising amount of rare metals. The theory says this is because a big celestial body collided with Mars and tore away a part of its northern half. Debris from that asteroid circled the planet and then mixed into 2 small moons that orbit Mars. We also have some Mars rocks on Earth, found in the Sahara Desert, Antarctica, and some other places across the globe. Some of these rocks have gas that's chemically the same as the atmosphere on Mars. Rocks probably came due to a big explosion that happened when some larger asteroid or meteor that was ejected from Mars and landed on our planet. Mercury also has a thin atmosphere, so there are many smaller strikes there. Imagine waking up, going to your window, and see there are micrometeor showers every morning, which is something that happens on Mercury. This strange weather pattern shapes its atmosphere, called an exosphere. Mercury is so dense, its heavy iron core accounts for 2/3 of its total mass. Scientists think it could have been bigger in the past, but many collisions got the surface sort of scraped off. It's been constantly bombarded by rocks from space that left marks with craters. Plains on its surface seem to have been created because of volcanic lava spilling over the surface and then dried smooth. Many craters are filled with such a material, which means there's one more thing that rocked Mercury's world: volcanoes. There's an unusual group of asteroids discovered near Neptune, wide range in sizes from big metropolitan areas to tiny pebbles. They are thought to come from an asteroid group called the Kuiper Belt. It makes a ring well beyond Neptune. But these new asteroids have different colors than the Kuiper Belt. They're so far away from the Sun, their surface was supposed to stay almost pristine, but they have a similar color to those sun-baked asteroids around Jupiter. Like the rest of the planets, Neptune gets heat from the Sun. But there's something mysterious inside the planet that makes it generate more heat than it gets. This affects its weather, and Neptune has the weirdest weather in the whole solar system. Massive storms, insanely high winds, cirrus-like clouds that rapidly change all the time. There are dark spots in its atmosphere. They come and go. We receive 1,000 times more sunlight than Neptune. Gas giants like Saturn and Jupiter can protect our planet from asteroids. Without them, the big impacts that created enough debris to form both moons and other planets would happen more often. There's a huge asteroid going around Saturn, which could be a potential flyby by 2031, more than 10 times bigger than the asteroid that erased the dinosaurs. Titan, one of the moons orbiting Saturn, 80% more massive than our moon, is actually the only moon in our solar system that has an atmosphere. It's 1.5 times thicker than ours and consists mainly of nitrogen, like our atmosphere. No one knows where all that nitrogen came from. However, unlike Saturn and most of the other places in our solar system, its moon has a real potential to host life.
Something's moving toward our planet that could end all life on Earth. It's a regular needle, weighing about 5 grams. You're probably wondering why it's so dangerous. Can something that small really do any harm? It's hard to say, because it's moving at the speed of light, and we don't really know what will happen when it hits. That's because the idea itself is hypothetical, so it leaves us with a bunch of questions. Here's the first one. What happens to a sewing needle in space? Could it actually accelerate to the speed of light? The short answer is no, but it's not that simple. In our universe, nothing that has mass can reach the speed of light. It takes energy to make any object go faster. Since there can't be an infinite amount of energy, nothing can ever accelerate that much. So in our case, we can simplify things. Let's say that the needle is moving at 99.9% of the speed of light. That's about 186,000 miles per second, or 670 million miles per hour. At this speed, the journey from the Earth to the Sun would take about 8 minutes. For comparison, the maximum speed of a Falcon Heavy rocket is 24,600 miles per hour. and the fastest car on Earth is more than 2 million times slower than the speed of light. The biggest rock to ever hit our planet was the Hoba meteorite. It weighed about 60 tons. It fell to Earth around 80,000 years ago and caused a lot of damage. Would something as small as our sewing needle be able to have the same effect? Sure it would. It's all about the energy involved. Small things traveling at almost the speed of light would have more energy in them than really big but slow-moving objects. So our speedy needle would hit the ground much harder. On impact, all the energy it contained would cause a mighty big kaboom. Everything nearby would just disintegrate. But could such a big explosion really destroy our entire planet? Let's compare this to the biggest blast humans ever made. The cloud of debris that followed this explosion was 40 miles high. It could be seen from a distance of 100 miles. About 50 megatons of explosive force was released into the atmosphere. The energy our needle would release as an explosion would be about 43 kilotons of force. That's less than what humans can cause, but it could still lead to massive damage. So if you hear on the news that something is headed for Earth at the speed of light, you'll definitely need to find some cover. Could people survive a collision like this? Well, it would be pretty scary. A dazzling flash of light would be followed by a shock wave of incredible force. The glass in all houses within a 2.5-mile radius would be smashed. Even the strongest buildings would collapse. All that energy coming from our needle would cause seriously big fires up to 1.5 miles from the epicenter. Everything at this spot would essentially be vaporized. The situation would be a little different if the needle went into the ocean. Just like a meteorite, its impact would cause a huge tsunami, but the shockwave wouldn't affect big cities, and people probably wouldn't be hurt. Although if it hit off the east coast of the United States, this tiny object could still cause flooding in New York. But other things could happen if a needle like this entered the Earth's atmosphere. Because it's moving close to the speed of light, the needle won't actually be a solid object anymore, but more like a bunch of atoms flying alongside each other. So it's possible that the needle would just pass right through our planet, the same way it would cut through a balloon. It would happen very quickly, in a split second. No one would even notice, and people would just go about their business. But here's the most incredible possibility. What if the needle hit a person? Well, there's a very small chance of that happening, just 1 in 1.6 million. Although something similar happened at least once, when 2 men in Turkey experienced rain made of rocks in 1888. But let's get back to our needle going at light speed. If the human body completely absorbed all that energy upon impact, it would just disintegrate. But there's another possibility as well. The needle could weaken the bonds between molecules and atoms in your body and pass right through them without causing any pain. You'd just feel something like a mosquito bite. Of course, it would still leave its mark. The needle would make a perfect hole in your body, but so long as it didn't go through your vital organs, you'd be fine. Plus, you could boast about your incredible good luck. The chance of a space needle hitting you is almost like winning the lottery. So it seems a needle moving at light speed wouldn't do that much harm. It might create a big crater in one spot, but the world would be all right overall. But what if something much bigger than a needle flew towards Earth? In 2013, a large meteorite entered the atmosphere above Russia. Luckily, most of it burned up before it reached the ground, but the largest piece of it that survived weighed slightly over half a ton. The meteorite exploded about 14.5 miles above the surface and lightly damaged more than 7,000 buildings. About 1,500 people were injured, but it was only moving at about 37,000 miles per hour. What would happen if it had accelerated to close to the speed of light? An object this big, moving at a speed of nearly 186,000 miles per second, would have an enormous amount of energy. Its impact would basically wipe out an entire continent. The blast wave would have such force that it would completely circle the planet and pull down absolutely everything in its path. The tsunami caused by the explosion would wash our civilization into the ocean. Humans would only survive if they made it to very deep underground bunkers. But once the dust settled and we went back up to the surface, we would find that there was nothing alive left on Earth. It would be more or less the same as when a meteor destroyed the dinosaurs millions of years ago. It's true that that meteorite didn't move as fast, but it was just as big. Of course, our planet recovered from that impact, and life returned. There is actually an object moving around in our solar system right now that could destroy half the Earth: Halley's Comet. It weighs about 220 billion tons. That's a whole lot of zeros. By the way, this comet has come close enough for us to spot it at least 30 times. The last time it could be seen was in 1986, but we'll have a chance to see it again in the not-too-distant future. Its next appearance is predicted for July 2061. If an object like Halley's Comet hit the Earth at the speed of light, it would completely change the shape of our planet. The blast would form a crater the size of Eurasia. After a blow like that, the Earth would never be the same again. Now let's talk about something that's a little more real, although it's seriously weird. Is there anything out there in the universe that can move at the speed of light? Well, almost. Scientists have discovered that some superactive galaxies can spit out hot blobs of gas the size of Jupiter. These galaxies are called blazars. When they studied the blobs, the scientists scratched their heads in confusion because the speed of these things is about 99.9% the speed of light. To accelerate something as big as a bowling ball to that speed would take all the energy produced on Earth for an entire week. So imagine how much you'd need to fire off a Jupiter-sized lump into space. The chances are that these blobs are getting all that energy from supermassive black holes inside the blazars. The hole itself absorbs tons of particles, but also accelerates others and pushes them out into space.
So one day, Edwin Hubble discovered that the universe was expanding, so they named a telescope after him. Well, yeah, there's more to the story. Now imagine a fruitcake baking in the oven. As this cake is rising, the raisins inside are moving farther apart. Something similar happens when the universe expands. But instead of raisins, there are galaxies, which start to spread out. That's why if you randomly pick any two galaxies, the chances are they're moving away from each other. But then the question is, if galaxies are moving apart, why are there still galactic collisions? You see, even while expanding, the universe still remains a playground for galaxies to interact with one another, and they mostly do it by using gravity. All galaxies out there attract other galaxies, and their mutual pull slows down the speed of them moving apart. And naturally, the closer two galaxies are to each other, the stronger their mutual gravitational pull is. On a large scale, it doesn't seem to make any difference, since every galaxy experiences a similar pull in every direction. But locally, gravity kinda overwhelms this powerful cosmic expansion and pulls together two or more galaxies which were initially moving apart. That's how galaxy collisions occur. Plus, some galaxy groups, like the Virgo cluster, aren't expanding at the moment, since local gravity has stopped the expansion process in that region. Some large galaxies can attract smaller ones, and then the gravity of the larger galaxy starts pulling a smaller one toward it. Eventually, it leads to a collision. Galaxies are made up of stars, rock, dust, gas, and other materials. When two galaxies collide, their gases begin to interact. These gases usually exist in large clouds spread throughout galaxy systems. Because of their size, large clouds of gases are more likely to run into large clouds of gases. Then they start getting denser and experience more pressure. Or the combination of gases can cause waves, and the gases can collapse on themselves. Both of these processes lead to the formation of new stars. If two colliding galaxies are of the same size, many new stars are likely to form, making the galaxies shine even brighter. But if the speed of these two galaxies is too high, the newly formed stars can go right out after they appear in the sky. As two galaxies start coming closer to each other, they begin to stretch and deform, creating arms or tails. As a result, an elliptical galaxy can form, or the collision can form a new supergalaxy. In this case, stars from each galaxy will have to find a new place within this gigantic space formation. But of course, there are tons of galaxies that have never collided with others. That's because galaxies are actually relatively small targets in our gigantic universe. They form groups of small clusters where dozens, hundreds, or even thousands of galaxies gather together, Gravity holds them tight together, just like the solar system stays together thanks to the sun's gravity. Galaxies roam within these groups and clusters in a disorganized way. Naturally, collisions are bound to occur, but since galaxies are tiny compared to all that space they live in, massive mergers don't happen often. I'm talking about those collisions between equal-sized galaxies that shake things up on a grand scale. Of all the environments galaxies can live in, the most dangerous place is a group. Because solitary galaxies, living out in the field, seldom cross paths with others. As for galaxy clusters, they are indeed crowded. But galaxies in them move at such breakneck speeds that even if two of them meet, they'll simply race past each other without any dramatic consequences. But groups of galaxies are a different story. There, galaxies move comparatively unhurriedly. It makes it more likely that two galaxies in a group will not only come close to each other, but also get caught in their mutual gravitational pull for a prolonged time. And what will happen if two galaxies come close enough to collide? Well, the best way you can imagine such events is by thinking of them as merges rather than collisions. Galaxies are very spacious, and it's more likely that the stars they contain will just pass by each other. Let's talk about a galactic collision that, according to astronomers, is going to happen in several billion years or so. And our home Milky Way galaxy is going to take part in this space event. But don't worry, we still have some time to brace for the impact. Interestingly, there might be not one, but two collisions. And the first one might happen around, 2 billion years from now, when the Milky Way will collide with the Large Magellanic Cloud. This spiral of stars and dust is floating in space about 160,000 light-years away from our galaxy. And although right now this distance is totally safe and you have nothing to worry about, in approximately 2 billion years, the two celestial bodies are likely to collide. And what a view it's going to be! Imagine the Milky Way nearing the smaller galaxy. The supermassive black hole residing in the center of our galaxy will wake up and start gobbling up the stars and gas clouds of the Large Magellanic Cloud with enthusiasm. Thanks to this new food source, the hole will grow way bigger than it is now. It might even turn into a quasar, one of the brightest things you can find in the universe. Our newly awakened black hole will also be emitting long jets of super bright radiation. But people on Earth won't have anything to worry about. These jets won't reach our solar system. And even if powerful gravitational interactions triggered by the merger could probably fling us out into intergalactic space, the chances of this happening are slim. Like me winning the lottery. Stars are located too far away from one another, and even such a catastrophic galactic smash-up isn't likely to jostle our solar system. Now, if our black hole does turn into a quasar, it'll be an even more breathtaking view. The thing about these celestial bodies is that their light can be up to 10,000 times brighter than the light coming from the whole Milky Way galaxy. That's why Earth's night sky might change beyond recognition. The newly born quasar will get rid of some stars and send others flying billions of miles away from their orbits. As a result, all the constellations, as we know them, will disappear from the sky after the familiar stars get too far away for us to see them with the unaided eye. Luckily, the chances that the Sun will get knocked out of the Milky Way are really infinitesimal. But how about the predicted collision with the Andromeda Galaxy? Will our solar system survive this catastrophe as well? Right now, the Andromeda Galaxy is nearing the Milky Way at a speed of 68 miles per second. As you may guess, it's very hard to figure out its actual speed. And until 2012, researchers weren't even sure if the collision was going to happen or not. Unfortunately, it turned out that we had to prepare for the appearance of Milkdromeda, or Milkomeda, a structurally new galaxy consisting of the merged Andromeda and the Milky Way. Now, on the other hand, such collisions aren't something out of the ordinary if you consider galaxies' lifespans. Besides, even though the Milky Way is home to more than 100 billion stars, and the Andromeda Galaxy contains about 1 trillion, the chances of several stars colliding during the galaxy's merge is really low. The reason is the same. Stars are located too far away from one another. For instance, the closest to our Sun star, Proxima Centauri, is more than 4.2 light-years away, which is about 30 million diameters of our Sun. In simpler terms, if the Sun was the size of a ping-pong ball, Proxima Centauri would be the size of a pea located 680 miles away, and the entire Milky Way would be 19 million miles wide. Wow! As for other stars, can you imagine ping-pong balls hanging in space every 2 miles? Great! Now you have a miniature model of our galaxy. Imagine something terrible happening to Earth and humans having to leave it as fast as possible, and you have to decide which planet will become your new home. Which one will you pick? Probably the first planet that comes to mind is Mars. It's relatively close. Like Earth, it's also a rocky planet. It even has an atmosphere, even though it's much thinner than what we have on our planet. But at the same time, the North Pole on Earth would seem balmy to you in comparison to Mars. On the red planet, the average temperature is minus 80 degrees Fahrenheit. The most radioactive areas on our home planet might seem harmless if you compare them with the surface of Mars. But what if we terraform Mars? Could we keep transforming the red planet until it becomes capable of supporting human life? It would be an enormous feat. Mars is an extremely dangerous place. Should you teleport there right now, without any protective suit or anything, the gas in your blood would instantly turn into bubbles. You can probably imagine the consequences. Add oxygen deprivation, cold exposure, and radiation poisoning to the equation, and well, who's next? If we still decided to terraform Mars, we would need to create a stronger magnetosphere. We've got this protective magnetic layer on Earth. It shields us from the sun's ultraviolet radiation. The red planet would also need a thicker atmosphere, again for protecting us from harmful space stuff better. Right now, the Martian atmosphere is almost entirely composed of carbon dioxide with tiny amounts of oxygen. For us to live there comfortably, Mars would also need to be warmer. And if we managed to somehow warm the planet up, we'd also be able to release frozen carbon dioxide. At the moment, there are vast reserves of this gas at the red planet's polar caps and other areas. It would help the atmosphere to become thicker, making it possible for water to exist on the surface of the planet. Right now, there is some water on Mars. The atmosphere of the red planet is too thin for this water to stay in its liquid form. But under the surface of the planet, it's a different matter. You can find water under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar Ice Cap. Also, sometimes salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. If liquid water existed on the surface of the planet, it would make it easier for us to start growing plants, and plants, in turn, would begin to produce oxygen. But first of all, we would need to start the warming process. How? Well, Elon Musk suggests using nuclear energy to make Mars more livable. He says it could be done by creating a continuous flow of low-fallout nuclear fusion explosions above the atmosphere of the planet. It could create something like numerous artificial suns. It could warm the planet, melting the frozen ice caps, which would then thicken the atmosphere, causing even more warming. Other strategies for Martian global warming include the diversion of asteroids into the poles of the planet, or the large-scale production of greenhouse gases that could help us heat the red planet. Or we could create a giant space mirror, as huge as the side of Mars. It would reflect tons of additional sunlight onto the planet. The problem is all these projects would have exorbitant costs. They would also require serious upgrades in our technological capabilities. Could there be an easier and cheaper way of terraforming the red planet? It seems so. Casey Hanmer used to work in NASA's Jet Propulsion Laboratory. Now he's the founder of a startup hoping to create carbon-negative natural gas by pulling carbon dioxide out of the atmosphere of our planet. He's also made a proposal to terraform Mars for a modest $10 billion. Sounds alluring. So, what is his idea? Mass-produce small solar sails. These are already existing technologies, even though they appeared only recently. Such sails use sunlight to propel themselves, like ships use the wind to sail. These solar sails could be launched into low Earth orbit, and after that, they would fly themselves to Mars. There, they would reflect sunlight onto the night side of the planet. According to Hanmer's calculations, a decade of such launches could result in a 1% increase in temperature on Mars. Hanmer also believes that we could mass-produce solar cells at cell phone factories, all because a solar sail would need a processor, a camera for navigation, and some electronics to be able to transmit data, just like a smartphone. In other words, solar sails would be like small satellites using cell phone technology. Each of these sails would also need a sail of its own, a thin space blanket weighing about 2 pounds. When unfurled, it would span around the size of 2 basketball courts. Would this plan involving solar sails enable people to terraform Mars? Hanmer doesn't think so. Even if we put loads of money into solar sails, they would only make the red planet warmer and more humid, but they still wouldn't be enough to make Mars suitable for human life. Most scientists are also very skeptical about the very idea of terraforming this cold, dry world. They say that carbon dioxide and water vapor are the only greenhouse gases present on Mars, but there's just not enough of them to change the situation. Let's say we manage to melt the polar ice caps with the help of Elon Musk's nuclear technology or solar sails. And still, this ice will only release enough carbon dioxide to bring the atmospheric pressure to 1.2% of what it is on Earth. Plus, most of the carbon dioxide gas wouldn't be accessible, and we wouldn't be able to mobilize it. Even if we decided to go through an energy-intensive process of the extraction of carbon dioxide from the planet's soil, dust, and minerals, we'd still only get the atmosphere to a mere 5% of where it needs to be. Water is another problem. It is salty on Mars. It might even be as salty as the oceans on our planet. But these salts aren't what you find on Earth. If a person consumed a certain amount of them, they would be highly toxic to the human body. Who's next? On our planet, these salts are formed as byproducts of rocket fuel, as well as in road flares and fireworks. Naturally, they only occur in very dry areas. If there are no particular bacteria to break them down, these substances accumulate year after year, and their concentration in water is constantly increasing. But in theory, it's possible to purify even such water. The process of filtration could help the astronauts get rid of 90% of harmful substances. Then they could use a UV disinfection unit. This would also help get rid of any foreign molecules, if there are any, that might be hiding in the water. This stage would not only protect the astronauts, but also prevent them from bringing any dormant Martian microbes back to Earth. In other words, future travelers to Mars shouldn't have too many problems with drinking water on the red planet, but only if they bring the right purification equipment that can deal with any water quality. Because however bad running out of water in the middle of a desert is, experiencing it on another planet sounds much more terrifying. Anyway, back to terraforming the red planet. Once you start thinking about it, some worrying questions arise. Who is supposed to decide whether we should start this process? When should we start it? What if there's some form of life on the red planet, like indigenous microbes we haven't spotted yet, and our attempts to change their home will disturb them? What if they don't survive these changes? Now, what do you think? Share your thoughts in the comments.
We just can't get enough of Mars, can we? Everyone wants to go there, and astronauts are now looking at caves on the red planet where they can live once people inhabit it. The planet itself has some similar characteristics to Earth. Yeah, it's somewhat smaller than Earth, but the time it takes for the planets to revolve around themselves is also similar, which is about a day. On paper, Mars might seem like a good idea given some similarities to Earth, but there are some factors we need to pay attention to before we consider stepping foot there. The temperature. Mars might look like a scorching hot planet like a freakishly large Sahara Desert, but quite the opposite. It's really cold. Mars has a reputation for being a freezing, desolate, endless land that happens to have the largest mountain in our solar system thus far. So, within those mountains, astronauts and scientists are considering whether naturally built caves are the answer to our survival. Caves won't be the worst thing we'd live in considering our ancestors used to dwell in caves in communities. Logically, it's the best place to stay dry during a storm and keep warm. It's the best place for protection against predators like giant birds, elephants, and saber-toothed cats. We even had our first art shows in caves with evidence of cave art dated thousands of years ago. Caves are a good idea, and they can also help us save a lot of money when establishing a colony on Mars. Rather than building a fresh structure in the middle of an open plain, the cave structure will help and influence the architecture, potentially saving lots and lots of money. Going to Mars will be expensive. It's already expensive sending people to the moon and launching a rocket into space. So, we have to consider the logistics. Another thing to look out for is caves in the ground that are not necessarily stuck on mountains. Scientists believe that most potential places for humans to thrive are caves. These spaces are large enough to host large populations. So far, they identified 9 caves as large as football fields. So what would life look like if we lived in caves on Mars? For one thing, sunlight would be hard to access. By the time we reach Mars, we would have the best technology to maximize our lifespan in a hostile environment, which means withstanding the harsh sun rays of Mars. Most likely, we would dig through the caves further underground where oxygen would be pumped for everyone to breathe. People can walk around casually, thinking they're on Earth, and to exit the caves, you would need to wear a special suit. These cave colonies would have dormitories for people to live in and special spaces for colony meetings, entertainment, grocery markets, schools, and other places that are needed to sustain a colony. There would also be indoor farms to grow crops and raise livestock. A team of experts mapped out what some of the dwellings will look like on Mars. And just like on Earth, we will have apartments for young professionals, family homes, and luxury mansions. Some of the dwelling units would be placed on the surface and not in caves. One of the key elements of the design and architecture is how to build it around the natural light to brighten up the homes. Another element is how to deflect radiation and cosmic rays. Because Mars has such a thin atmosphere, sun rays and other hazardous objects easily enter Mars. The dwelling units also have to be sturdy to protect them from severe dust storms and extreme cold temperatures. Some of the living pods or dwelling units that are for couples or singles would have tunnels leading to a shared workspace and garden. Studies show that even being in the presence of greenery can reduce stress levels significantly. And on the red planet, we would definitely need some greenery. We can expect the family homes to be built within the caves, not necessarily underground. It would be tempting to head outside with the view of Mars, but the large thick glass would prevent anything from coming in and out. Those who are underground with a view rely on LEDs and camera systems to screen the surface landscape of Mars so it acts like real windows. And if you're bored of the surface, you can always switch the channel and watch something else as you please. Maybe a flowing river surrounded by trees, or maybe a penthouse view of all of New York. The choice is yours. There would be a driveway that leads to a garage so one can enter and exit easily. There won't really be a reason to exit the cave colony except probably to visit other cave colonies. In this case, we would have highly crafted vehicles that will take people from colony to colony on the surface. The vehicles can withstand harsh temperatures and would be constantly transporting people daily. Some people might live in a certain colony and have to commute to work every day in other colonies. Humans might not have to be working in dangerous conditions or on the surface. We would have robots that will do that for us. The thing about robots is that they don't need to be human-shaped to do a job. However, before transporting humans to space, we would need to create some human-like robots and land them on Mars. with the exact physical form, we can determine what would happen to people if they were on Mars. We would have robots for specific tasks, helping us with everything. Let's not forget artificial intelligence plays a major role in monitoring the systems and updating the functionalities of the colony. It'll know when certain systems need fixing, adjusting, renewing, and changing. We also need people to keep an eye out for anything out of the ordinary, and also to make sure people are behaving and not breaking the law. Getting to Mars would be the earliest obstacle we will face. We've already launched some robots to explore the terrain and conduct some studies. At first, we would send robots to test the conditions and to build most of the infrastructure. To build a proper colony, we would have to send out young couples willing to dedicate their lives to the future and the future of their children. It won't be easy. In fact, there would be a variety of people with different professions and specializations to help establish the colony. People would have to work and establish a local economy. We would need scientists, doctors, farmers, teachers for the children, and engineers to maintain the structure. It will take time for the colony to reach a substantial size, but it's all part of the process. Even the spaceships would need to be large and sufficient to house thousands of people traveling from Earth. Of course, by then, most of the dwelling units would have been built, and people would have already picked out their houses, depending on if they were single or if they were about to start a family. Once the colony has the necessary professionals it needs, then come the other people who wish to start their life on Mars. People would need entertainment, so musicians would find a place in the colony. We can't expect everyone to go out on a nice sunny day to the beach, but perhaps one day, when the colony is large enough, there can be an artificial body of water with the same elements as the beach. Livestock animals would also be shipped from Earth to be raised on Mars, where they can populate for our nourishment. We can also bring most of the animals and establish a wildlife sanctuary for everyone to enjoy and for the animals to thrive. For now, humans are planning on reaching the Red Planet sooner than we think, and who knows, maybe you can be one of the first people to sign up and have your own little dwelling unit far away from Earth. So Mars has two moons, Phobos and Deimos. And apart from the bizarre shape, there's nothing remarkable about them, except for one thing. Not so long ago, scientists discovered a strange phenomenon on the surface of Phobos, and they still can't find any explanation for it. What is this phenomenon, and what does it tell us about the history of our solar system? Let's find out. American astronomer Asaph Hall discovered Phobos and Deimos back in 1877. Did you know that all the planets in our solar system are named after Greek and Roman deities? For example, Mars or Ares is the famous deity of war. That's why the satellites of this red planet were named after the sons of Ares, Phobos and Deimos. These beautiful names actually have creepy meanings: fear and horror. In 1971, NASA's Mariner 9 telescope took the first pictures. That's how we found out that these guys weren't at all like our moon. They had this weird shape, a strange and unstable orbit. Moreover, there are no other moons in the solar system that move as close to their parent planet as these two. Well, they are its sons after all. But even though they are very close to Mars, if you were standing on the surface of the red planet, you would hardly be able to see them. That's because the curvature of Mars hides Phobos and Deimos from view. Even if you were somewhere on the equator, Phobos would look like an ordinary asteroid to you, and Deimos would look like a star. All because these satellites are basically crumbs compared to our moon. They're the smallest and least bright moons in the entire solar system, which is ironic considering their mighty names. Anyway, it seems that everything should be pretty clear with these two satellites. But nope, there's a problem. You see, scientists reconstruct the history of space based on the traces found on different space objects. Dents, scratches, cracks, all these things can tell us what happened billions of years ago. For a long time, scientists were sure that, just like their Greek prototypes, Phobos and Deimos were twins. But then, NASA's Viking orbiter took new photos of the satellites, and that's when they discovered a significant difference between the two. The entire surface of Phobos was covered with huge grooves. Those were a series of long, deep pits stretching from one end of Phobos to the other. You may say, what's the big deal? All space objects have this kind of stuff on them. And yeah, there are other satellites with similar grooves and scratches, but none of them has as many as Phobos. It's completely covered in grooves, and they're huge, up to 12 miles long and 660 feet wide. And that's not all. Some of these grooves intersect with others. This means that Phobos has experienced not one, but many traumatic events. But what exactly happened to it? Actually, scientists are still not completely sure. However, they have a few ideas, and these theories can tell us not only about the past of Phobos, but also predict its future. Theory 1. Asteroid impact. Well, the first suspect is quite obvious. There's a large, almost 6-mile wide crater on Phobos. It's called Angeline Stickney. It was named after the wife of Asaph Hall, the scientist who discovered the satellites. Adorable. So that's what the first theory sounds like. Once upon a time, an astronomical body crashed into Phobos. The impact was so strong that it left a large crater. And the effect of the collision left a bunch of grooves everywhere on Phobos. It sounds logical at first. However, scientists have noticed a flaw in this theory. They learned that these grooves actually formed not inside the crater, but next to it. So it wasn't a collision that created them. Besides, what about those grooves that intersect with the others? Or is it just a big cosmic coincidence? Well, the search for truth continued. Theory 2. It's all because of space debris. Yes, there's a difference between these two theories. In this case, the grooves aren't a direct consequence of the collision. Rather, it goes something like this. Something crashed into Phobos. This impact caused a bunch of rocks to be thrown into space. Some of them were lost in the universe forever, but others were small enough to be pulled back to Phobos. Passing next to the moon at a steep angle, they would crash into it, jumping away, and so on. And since the gravity of Phobos is very weak, perhaps they couldn't stick to it. In other words, these rocks were continuously pulled toward and pushed off of the satellite for many, many years. This theory explains the intersecting grooves. It's because the rocks were constantly falling into those places. It sounds quite logical, but there's another problem. We don't see any boulders on Mars or on the surface of its moons. But all this debris was supposed to get trapped by gravity and remain somewhere in the planet's orbit. This, or simply become part of Phobos. In other words, if this were true, we'd find evidence of this theory under layers of dust. But that didn't happen, so this explanation didn't satisfy astronomers either. Therefore, they continued to look for the culprit. Maybe the grooves have nothing to do with Stickney Crater at all. Maybe the real culprit is something else, something even more powerful. Could it be Mars itself? Theory 3. Mars is a twist villain. The previous theories imply that Phobos and Deimos were originally pieces of Mars. Like once upon a time they broke away from it and became satellites, just like our moon. But what if that wasn't the case? Observations made by NASA's Mars Global Surveyor show that Phobos and Deimos are made up of elements which are mainly found in meteorites and asteroids. So, what if Phobos and Deimos are asteroids? There's an asteroid belt between Mars and Jupiter. Given the size, shape, and composition of Phobos and Deimos, scientists have suggested that once upon a time they belonged to this belt. However, one day they flew out of it, and then gravity pulled them to Mars. This phenomenon is called asteroid capture. It's very strange though. Yeah, the asteroid capture isn't uncommon, but these two have been flying next to Mars for what, billions of years? It's weird that their orbits have remained the same. In addition, the atmosphere of Mars is very rarefied, and because of this, it could hardly capture any asteroids. In theory, they should have separated from Mars at the first opportunity. However, this didn't happen. It means that somehow they got stuck, and Mars immediately began to destroy them. Yep, an unexpected twist. In this version, Mars turns out to be a villain. By studying the past, we've found some evidence of future crimes. The mysterious grooves of Phobos could be caused by tidal forces between Mars and Phobos. The Moon and Earth also exchange these, slightly distorting each other. But since Phobos is much closer to Mars, the impact of gravitational forces is much stronger. In other words, the gravity of Mars is gradually destroying Phobos. Every 100 years, the satellite gets 0.7 inches closer to Mars. It also shrinks as much as 6.5 feet, becoming even more fragile and weaker. The smaller it gets, the more the tidal forces impact it, creating strange grooves and scratches on Phobos. Yep, somewhere in 30 to 50 million years, Phobos will either collide with Mars or disintegrate and turn into a bunch of small rocks. And then Mars will also have rings, like Saturn and Neptune. That's why Phobos is called the doomed Martian moon. Anyway, these are all only theories, but the dramatic backstory of Phobos gives us an idea of how dynamic extraterrestrial objects can be. The more we learn about them, the more we discover about the secrets of the origin of not only Mars, but also other objects in our solar system. If one day we really colonize Mars, studying its moons can help us a lot. Let's hope that the upcoming MMX mission will reveal some of the most exciting secrets Mars's moons are hiding.
We've sent more spacecraft to study the local environment on Mars than on any other planet. We have no evidence that life exists on the red planet or ever did, but that didn't stop some people from wondering. Mostly because of the pictures that NASA's Perseverance and Curiosity rovers take regularly of Mars' surface. Feel free to check them out for yourself on the internet. They are free for anyone to see. Over time, some odd shapes have appeared here and there in these pictures, making some people believe there is some sort of creatures living there already. Back in 2008, one of the rovers took a picture of a rock that looked very much like a female figure. Other photos seem to show animal-shaped figures, utensils, or other Earth-like objects. Again, there is little to no proof of this theory, as rocks can be of all sorts of shapes and sizes. But if you look at the pictures, it does make you wonder. A lot of people in the scientific community do see Mars as a better place for long-term settlements, even though our moon is closer. Firstly, because it believed there is indeed water on Mars. It's just stuck in underground frozen lakes. The soil doesn't seem to be rich in nutrients, and it may have some harmful chemicals. Moreover, on the red planet, the gravitational pull is only 38% of Earth's, so it's easy to carry heavy objects here. On our moon, for comparison, the gravitational force is only about 16 and 16% of that found on Earth. We already have people studying how we might live on Mars right here on our planet. It's because certain regions of Earth closely mimic the harsher conditions on Mars. Devon Island, for example, is the biggest uninhabited island on our planet, located in the Canadian Arctic archipelago. It's easy to see why it's hard to live here. The soil stays frozen all year. The eastern part of the island is covered by a thick ice cap all year round. Summers here only last for less than 50 days and aren't really that warm. Not a lot of plants can grow here, so no animals can adapt to thrive and multiply. As such, the Hutton Mars project started here in 1997 to offer astronauts unique studying opportunities. There are few options here in terms of logistics and transportation, and communicating with people living outside the island is also a bit more difficult. All because of the temperature and barren soil. Think about it, if we can find solution to live here, we might be able to do it on Mars too. Regardless of our local training, the conditions on Mars are currently inhospitable. That's because it's really cold. On average, the temperature is about -81 Fahrenheit. Even during the summertime, it's never hotter than 86 Fahrenheit. And to top it all off, the planet's atmosphere is made of 95 3/10% carbon dioxide, so there's literally no way we could breathe there without special devices. Mars also lacks a magnetic field on its surface, so it is attacked by the sun's radiation. Because of the temperature variations, Mars often experiences powerful dust storms, which can surround the entire planet. Technically, these storms can physically harm us, but the dust might clog electronics and render solar-powered instruments unstable. We know now that life as we know it is impossible on Mars, but did it ever exist there? This is a question long debated by scientists, since NASA's investigations have determined that some parts of Mars were habitable at one point. We don't know for how long or how far back, and just because something could have lived there, it doesn't mean it actually did. Other recent photos from Mars showed a cloudy sunset. Does that mean it also rains on the red planet? Well, not really. For starters, on our planet clouds are water vapors, and once it starts to rain, the water reaches the surface of our planet in liquid form. This process isn't the same on Mars. Surprisingly, there is more water in Mars clouds, but they're made of iced water. Think of them as a tiny icy fog. Combined with the thin atmosphere and cold temperatures, it keeps the clouds from ever falling to the surface. Sunsets are different here too. According to NASA specialists, there is some fine dust that makes the blue near the sun's part of the sky much more visible on Mars, so the sunsets here have more of a bluish tint. Similar to Earth, Mars is also tilted on its axis, which means it also has seasons. Because the southern hemisphere is directed away from the sun when Mars is farthest from it, the winters here are far colder and summers way hotter. Calendars work differently on Mars too. A year here lasts for about 1 1/8800th Earth years. A day is a bit more longer than 24 hours. Even if we were to ever move to Mars, we'd still have to communicate with our Earth. It would be a bit difficult to do, since a message sent back home would take about 15 minutes to reach its destination. It's not that bad given the entire distance, but it would make video calls kind of annoying. As difficult as it might be for now to live there, there is a lot of stuff to see. Some scientists believe that if we were completely colonize Mars, a list of locations would soon be declared national parks, like the area surrounding Olympus Mons, which is the biggest known volcano in the solar system, stretching over 16 miles. Valles Marineris would be another cool location. It's been a huge complex of valleys about the distance from Los Angeles to New York. Mars also has some cool polar ice caps, which sometimes experience dry ice snowfall. Saturn and Uranus are unique planets in our solar system because of their rings. It may not have one now, but Mars may be getting a ring of its own in the future. Don't get too excited. It's estimated it might take 10 of millions of years. Mars' largest moon, named Phobos, will be torn apart at one point. The debris resulting from it will settle in a rocky ring around Mars, resembling that of Saturn and Uranus. Speaking of moons, Mars has 2 of them that we know of. Apart from Phobos, there is also one more object called Deimos. Both were discovered by an American astronomer named Joseph Hall back in 1877. The scientist had almost given up his pursuit to find Mars moons, but thankfully he was urged to continue the project. The next night he stumbled upon Deimos. 6 days after that initial finding, Hall found Phobos. These 2 space objects may be in fact some asteroids captured by Mars gravity. Another theory suggests they formed in orbit around Mars at about the same time the planet came to be. The fact that Mars has a really weak gravity may also be the reason for this fascinating event. Mars was hit by large asteroids many years ago, just like our planet was. A lot of that debris surely went back to the surface, but some of it was ejected back into space, as Mars' gravity wasn't strong enough to pull them back. They had quite a journey, some of them even ended up on Earth. These pieces of Mars also helped us understand the planet's unique features. We've continued to send robots to the Red Planet quite successfully in the past few decades. but it still remains quite difficult to imagine people will soon land on Mars. Even considering the current rocket technology, the journey would take us 6 months. And that's an optimistic scenario, given everything goes well on board. After landing, humans will be exposed to deep space radiation and microgravity. Both of these have serious effects on the human body, which we've yet to figure out how to counteract. That's why research is continuously performed on the International Space Station regarding the long-term effects of microgravity.
It's staring at you, and you're staring at it. A giant eye that seems to be pulling you into an abyss. You're hovering over it in your spacecopter. But however scared you might be, you still need to do your job. So you send your copter down to the surface of the red planet. Right, that's where you are, on Mars. But first things first, you take a moment to remember everything you know about the fourth planet from the Sun. It's the last of the inner planets. Those are the planets that lie within the asteroid belt. They're also called terrestrial, since they're made up of rocks and metals. The atmosphere of Mars is much thinner than Earth's. It contains 95% carbon dioxide and a mere 1% of oxygen. In other words, don't even think about pulling off your helmet. Anyway, there's no time to waste. You land on the surface of the planet and find yourself in a brownish-red world. That's a good thing you're wearing a spacesuit. This place is freezing cold. The thermometer sewn into the sleeve of your suit shows minus 80 degrees Fahrenheit. Time to take your first step on the Martian surface. The planet looks quite colorful, and the hue of a particular area depends on the minerals that make up the soil. The ground under your feet is covered in fine dust. It looks like rust. The same orange dust is in the air. Good thing you have your own supply of oxygen and don't need to breathe Martian air. The layer of this dust covering the surface of Mars can be from 6 to 40 feet thick. You hope you'll avoid getting swallowed by some Martian quicksand. You start walking, feeling very light. Mars is just 15% of our planet's volume and a mere 11% of Earth's mass. It means that gravity here is much weaker. Its pull is 38% as strong as the pull of gravity on the surface of Earth. You jump up and down and then try to run several hundred feet. Ha! You haven't even broken a sweat. What makes it harder for you to explore the place on foot is that the planet's surface is rocky, covered with craters and volcanoes, old dry lake beds, and canyons. You see something huge towering on the horizon, but you try to suppress your curiosity. You'll have enough time to figure out what it is later. Suddenly, a massive cloud appears in the distance. It looks as if a huge herd of horses is approaching you. In reality, you better get back into your copter and fly away as fast as you can. That's one of Mars's infamous dust storms. They mostly occur during the summer in the southern hemisphere of the red planet. They can sometimes cover the entire planet, and you see the largest ones from Earth. You hop into your copter and set a course for the eye that scared you so much. Winding channels that look like veins run through the eyeball. But the closer you get, the less it looks like an actual eye. Soon you realize it's a crater. It's giant, almost 19 miles across. Around the crater, which looks as if it has a pupil, there are other even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once there was Martian water in the enormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Now, remember that towering something on the horizon? It's time to go and explore it. When you come close, you realize it's the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which is almost the same size as the state of Arizona. You tilt your head. Wow! The mountain is 16 miles high. It's also rimmed by 4-mile-high cliffs. To picture the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, towering around 2.5 miles above sea level and stretching 75 miles across. Sounds impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. But why is this volcano so large? It might be the result of lower surface gravity and higher eruption rates. Or the reason might be the red planet's crust, which is very different from Earth's. It's static. You see, on our planet, the crust is made of 15 to 20 moving tectonic plates. As plates move over hotspots producing lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. So, how about getting closer to the enormous mountain? But once you step out of your copter on Martian soil, the ground under your feet starts shaking. Well, that's a Marsquake. But how can it happen if Mars doesn't have any actively shifting tectonic plates? Specialists from NASA are sure Marsquakes occur when energy inside the planet gets suddenly released. It leads to rock fractures and cracks in the planet's crust. Another powerful jolt, and one of such cracks opens right next to you. You fall to the ground, afraid to move, but soon everything calms down. You wait for a couple of minutes, just to be sure, and get up. Oh look! Here's a perfect opportunity to explore the insides of the red planet. The crack is large enough to send a special research robot. The planet's crust is thin and consists of volcanic basalt rock. The mantle that surrounds the core of the planet is made up of thick silicates, oxygen, and some minerals. You can probably compare it with soft, rocky toothpaste. Mars's mantle is also much thinner than Earth's. It's just 800 to 1100 miles thick. As for the planet's core, it's made mostly of iron, nickel, and sulfur and is between 900 and 1200 miles wide. This core doesn't move. That's why Mars doesn't have a planet-wide magnetic field. Unfortunately, your drone is now lost in the depths of the red planet. You leave it there and continue your exploration. Your next destination is Valles Marineris. It sounds more like an Italian red sauce, but it's actually an enormous canyon, or rather a canyon system, that runs along Mars's equator. It's as awe-inspiring as Olympus Mons, more than 2,600 miles long and over 4 miles deep. The thing is so huge, it could span the entire continental United States from the Pacific to the Atlantic Ocean. Now let's make another comparison. One of the most famous canyons on Earth is the Grand Canyon in Arizona, but it's 10 times shorter and around 4 times less deep than this canyon on Mars. Some scientists think that Valles Marineris is the edge of an enormous tectonic plate. It moves so slowly that almost nothing has happened in that region over millions of years, and the movement of this plate probably began 3.5 billion years ago. Anyway, the only thing left on your today's to-do list is to visit Mars's moons. They're among the tiniest in the solar system. Phobos is the largest of the two. It orbits a mere 3,700 miles above the surface of Mars. There's no other known moon that travels closer to its mother planet. It whips around the red planet 3 times a day, while the second moon, Deimos, needs 30 hours to complete one orbit. Phobos is getting closer and closer to Mars, about 6 feet each 100 years. Within the next 50 million years, it'll either crash into the planet or break apart and form a ring. Happy but tired, you return to your spaceship. Tomorrow, you'll continue exploring the magnificent red planet, and who knows what discoveries are awaiting you.
You wake up in your ultra-modern dwelling, go out on the balcony, and admire the incredible sandstorm in the distance. The reddish wall is approaching and has already reached the parking lot where your shiny Starship rocket stands. When the storm subsides, you put on your spacesuit, get in your rover, and drive to work. Your job today is to monitor the instruments in the freshwater extraction plant. In the evening, your shift ends and you return home. The cooking robot has already prepared dinner, fried potatoes, grown right here on Mars. This scenario could be true as early as 2050 and even sooner. Elon Musk plans to send 1 million people to Mars by then. Very ambitious, but incredibly difficult to accomplish. Flying to Mars is very expensive and time-consuming, and it consists of several stages. We're heading to the launch pad. where the first Starship is being prepared for takeoff. The rocket consists of two parts. The first is the Super Heavy booster. It'll help the heavy craft overcome the Earth's gravity and leave our planet. It should take Starship into orbit, then undock and land back on Earth. At that time, Starship has to hover in orbit, having used up almost all of its fuel during takeoff. The next step is to refuel Starship right in orbit. The booster takes off again from the launch pad and carries fuel for the main spacecraft. Starship is still empty because we don't want to spend a lot of fuel to lift it out of orbit. So now, it's time for another booster rocket to carry a payload for Starship. Food, construction materials, and research equipment are stacked in the cargo bay. All set at last, our spaceship sets off on its long journey towards Mars. This is how just one ship is planned to be launched, but it can only hold 100 people, while we're planning to send 1 million there. That's almost half the population of Brooklyn. That means we'll need at least 10,000 ships for the whole mission, and even more booster rockets to refuel and send cargo into orbit. Considering that one Starship costs about $8 billion, this mission would cost a pretty penny. The key to solving this problem is reusing these ships. Once the ship has delivered people to Mars, it should be refueled and sent back to Earth for the next batch, sort of a space bus. Another problem is time. The orbits of Earth and Mars aren't perfectly circular. They're of different lengths and make circles around the Sun at different speeds. When Earth and Mars are at their farthest apart, the distance between them is about 248 million miles. And the closest distance, when the Earth is perfectly between the Sun and Mars, is 34 million miles. This is our target. Once every 26 months, Earth and Mars meet at this distance, so this is the perfect time to launch a rocket to keep the flight time as short as possible, between 6 and 8 months. If the first flight is scheduled for 2025, and we plan to complete the mission in 2050, we would only have 12 such flight windows. We would need to launch at least 833 ships in each window. Then there's weightlessness. On a trip to Mars, astronauts will spend more time in zero gravity than people now spend on the International Space Station. Without gravity, people's muscles weaken. Even the distance between their vertebrae slightly increases. So, during the missions, astronauts actually become a bit taller. Throughout the voyage, the team will have to constantly train in the gym to be ready for the hard work upon arriving on Mars. In addition to ships with people on board, cargo ships will also be needed. When people arrive on Mars, they will need to build an entire city from scratch. Construction materials, tools, machines. The massive cargo Starship can take on board is about 75 tons. That's about 30 SUVs. So, we'll need a lot more ships to get everything we need. And that doubles the cost of the whole mission. There's a cheaper way to get to Mars, though. The Gateway Station on the Moon. It's kind of like the ISS, only it orbits our natural satellite. It'll also have many modules for astronauts, living bays, storage bays, docks for ships, and research units. The whole point is that it's much easier for a spaceship to launch from such a station because there's no gravity. And then, the ship doesn't have to use an incredible amount of fuel to leave the Earth's atmosphere. It took about $100 billion to build the ISS, and building Gateway could be even more expensive. But it should save us money in the future. The small Orion spacecraft will lift astronauts from the surface to the station. Then, after preparation, the astronauts will go on a long journey to Mars. Let's go a little bit forward in time. The first few ships have delivered their load on the surface of the red planet. Beach umbrellas and deck chairs will have to wait because it's time to build the city and prepare for the arrival of the next group of people. The priority is energy. For this, we can use solar panels like on Earth or nuclear power plants. The next step is to build houses. Because of the lack of atmosphere on Mars, nothing will protect us from the sun's radiation. So a great option is to build houses underground. Now we need to take care of water extraction. There are ice caps at the poles of Mars. We can take water from there. Then, Oxygen. Plants have to help us do that. There's a lot of carbon dioxide in the air of Mars, which serves as a kind of food for green plants. And as a waste product, they release oxygen. All we have to do is collect this oxygen and use it to breathe. Sooner or later, the food we bring with us will run out, so we'll have to grow food directly on Mars. This requires fertilizers and greenhouses. Now that everything else is taken care of, the main task is to produce fuel. We need it for vehicles on Mars and for rockets to be able to return home. Fuel can be extracted from the carbon dioxide in the atmosphere and water. All this has to be done in completely unfamiliar conditions. Gravity on Mars is 3 times weaker than at home. You'll be able to jump higher and lift heavier objects, but prolonged exposure to such weak gravity can harm our bodies. Now that there's a whole city on the planet's surface, it's time to turn Mars into something more comfortable, resembling Earth. This is called terraforming. We need to increase the pressure in the atmosphere so that water can exist here not only as a vapor or ice, but also in liquid form. We also need to raise the temperature of the surface. Our goal is about 68 degrees Fahrenheit. Right now, it's about -81 degrees Fahrenheit on average there. Then, we need an ozone layer, like on Earth. It should protect us from solar radiation. Finally, we can start creating the biosphere. That's all living organisms, plants, and animals. Gradually, Mars will start to resemble Earth in its best years. For all this, scientists have come up with many solutions. For example, a large asteroid could be dropped on the surface of Mars. This would warm up the atmosphere and bring more water and gas there. The planet could also be populated with different bacteria. In laboratories on Earth, scientists have simulated conditions on the surface of Mars and realized many bacteria can survive there. As long as they live, they can release oxygen and other gases into the air. Besides that, we can build biodomes. This is a kind of greenhouse with favorable conditions. Life will develop in it, and the soil of Mars will gradually become suitable for life. And one of the easiest ways is the greenhouse effect. On Earth, it contributes to global warming, but on Mars, gas emissions from cars and factories can help create an atmosphere. Optimistically, it could take 300 to 1,000 years to change the face of the red planet. Other scientists say it could take millions of years. Only then will humans finally be able to take off their spacesuits and oxygen masks and call Mars home.
Dust storms on Mars can really go crazy. They hurtle through the red planet's southern hemisphere, especially during the summer. These storms can grow and encompass large areas of the planet, as happened in January 2022. Then, a dust storm covered almost twice the area of the United States. Could it be something like this that caused one of the robots we sent to Mars to go missing? The atmosphere and climate are harsh on Mars. It's mostly a desert with strong winds and average temperatures of -81 degrees Fahrenheit. It drops down to -220 at the poles during the winter. A lander needs to be specifically equipped and very sturdy to withstand such conditions. But researchers thought the Beagle 2 could handle the difficult trip to the red planet. June 3, 2003. A team of researchers got one of their pioneering robots they were about to send to space ready. It was a small and compact lander called the Beagle 2. Its mission was to touch down on Mars and search for what the world has been actively looking for decades now: life on the red planet. Now, the touchdown was due on December 25th, but the signal never came. The team tried to contact the spaceship, but at one point, they had to accept they wouldn't be able to reach it. Some thought the landing was too difficult and complex after all, so the lander crashed. But they couldn't find any technical errors. Others had a theory that the lander may have become entangled in its own parachute and fell down to the surface of Mars. Either way, the Beagle 2 was considered missing, until 2015, when NASA took pictures of what could be the remains of the lost lander. They weren't just smashed debris, the components actually looked to be intact. The lander's remains were lying with its solar panels partially deployed around 3 miles away from the site where it was supposed to land. Apparently, the Beagle 2 managed to land successfully, but its radio antenna got blocked. That's why researchers couldn't control it from Earth or communicate with it. But no one knows exactly why it happened. Have you heard of a face on Mars? In the 1970s, one of NASA's spaceships took the iconic images of the Martian surface that showed a face-like formation, as you can see in the upper part of the picture. If you have a rich imagination, you can easily see a nose, 2 eyes, a mouth, and an unusual hairdo. Some even thought it was a monument built on the red planet by another civilization. How about some other unusual things people have found on Mars, like Happy Face Crater? You can easily see why it has this nickname. Or rocks in different shapes, a pancake, brachiosaurus, or a fish. Mars also has a waffle-shaped island on its surface. It's a 1.2-mile-wide feature you can see in the area of lava flows. It might be the result of lava pushing this formation from below. It seems astronomers have also got some images of blue dunes. It's a sea of stunning dark dunes that strong winds sculpted into long lines. They surround the planet's northern polar cap and cover a region as large as Texas. The red planet is usually known for its brown sandy dunes, so these ones certainly came as a surprise. In reality, though, they're not really blue. If you could visit Mars right now just to take a look, you'd see that these dunes appear brown and orange like the rest. And the picture is a false color image. Scientists often use false colors to highlight differences in something. For example, here it's the difference in depth. Also, the biggest valley on Mars is so large it could eat our Grand Canyon for breakfast. It's a fascinating system of canyons 2,500 miles long called Valles Marineris, and it's over 10 times as long as the Grand Canyon. Now, if you could stretch this Martian canyon, it would go from coast to coast of the entire United States. Since Mars doesn't have any active plate tectonics, no one knows for sure how this canyon formed. One theory says a chain of volcanoes located on the other side of Mars, the one that includes Olympus Mons, bent the crust from the opposite side of the planet. This powerful force caused cracks in the Martian crust, as well as activated enormous amounts of water lying under the surface. This water then emerged and carved the rock away. The force activated glaciers too, and they possibly created new pathways in this gigantic canyon system. Volcanoes on the Martian surface could have erupted about 50,000 years ago, although the most powerful eruptions happened 2 to 3 billion years ago. But the planet doesn't have active volcanoes today. Most of the heat stored in its interior during the planet's formation has been lost. So now, Mars's outer crust is way too thick for the molten rock to reach the surface. But a long time ago, eruptions formed giant volcanoes, and these volcanoes most likely had an important role in melting ice deposits, which released floods of water onto the Martian surface. Now, Mars has a thin atmosphere with a volume of gas, mostly carbon dioxide, less than 1% of Earth's. But 4 billion years ago, it was way warmer and wetter than now. Its atmosphere must have been thicker back then, too. That's why it could create a powerful greenhouse effect and trap sunlight. Mars also has a powerful magnetic field. Similar to Earth's, it formed because of the currents of molten metals in the planet's core. But unlike our home planet, Mars lost its magnetic field after its core had cooled down. And without it, the planet didn't have any protection from the solar wind, which is a stream of charged particles flowing from the sun. The solar wind pulled away most of Mars's atmosphere in just a couple of 100 million years, give or take. This is what makes those powerful Martian dust storms even more intense. Mars has a fascinating history. Judging by the planet's glaciers, Mars has probably gone through multiple ice ages, just like Earth. A team of researchers got images of about 60,000 Martian rocks. Rocks were different in size and distributed randomly, which means they probably formed during different ice ages. Glaciers hide their own stories too. Who knows what kinds of gases, rocks, or even microbes could be trapped inside? Now, if you could get into a time machine and stop at 4 billion years ago, on Mars of course, the chances are you would see spectacular scenes of flooding. Maybe there would even be some form of life on the planet's surface. A strong meteorite impact that formed the red planet's Gale crater could be something that triggered that mega flood. After that collision, the temperatures on the planet got insanely hot. This caused the melting of all that ice that was stored on the Martian surface at that time. The flooding was so massive, it changed the geological structure of the planet's surface. It carved out big ripples, as well as waves in the sedimentary rock. Now, speaking of water, vapor has been noticed escaping the atmosphere of Mars. Also, researchers have found some evidence of water flowing on the planet's surface. There are dark streaks in the soil. They seem to get bigger in the summer and shrink over the winter. There are numerous dried-out valleys and river channels on the planet. It's possible that liquid water once flowed there. Now, most of it could be locked up in ice caps or even hidden under the surface. More and more things hint that Mars used to be habitable. Mars is the only planet we know about where only robots live. 5 rovers make up the Martian population. Those are Perseverance, Opportunity, Spirit, Sojourner, and Curiosity. These robots are there to take pictures and samples of soil and air, and maybe even find life on the red planet. And someday, we may reunite with them on Mars. Who knows? Oh, and by the way, if you really could get into a time machine and stop at 4 billion years ago on Mars, then I'd like to buy you lunch and talk about it. My treat.
There are almost no similarities between Earth and Jupiter. Ours is a sweet, small planet with plants and cute pandas. Jupiter is a giant gas horror with furious hurricanes which never subside. And if you fall into this planet, you might literally fly through it. But what would happen if our Earth was the size of the father of the solar system? Oh, this is going to be fun. Jupiter is a planet so big that I bet you can't even imagine its scale. Its radius is about 11 times the radius of Earth, and it's about 316 times more massive. So, to turn Earth into another Jupiter, we'd need to increase its radius by 11 times. If the planet's density remained the same, then the mass of our new Earth would increase greatly. Actually, it'd be as much as 4 times larger than Jupiter's. Of course, these changes wouldn't go smoothly. The very first thing that we would immediately notice, nope, not the size, gravity. It would increase by about 11 times compared to old Earth's. Scientists say we can actually survive on a planet with greater gravity, but only if it's less than 5 times stronger than what we have now. Well, let's assume that we're daredevils, always ready to challenge nature. What would our life be like? Well, not very pleasant. After each step, you'd have to sit down on a bench and take a break, as if you've just run a marathon. Yes, it would be that hard to walk. Oh, and good luck with getting up later. In order to somehow move around this planet, we'd have to pump up very strong muscles. No more problems with junk food, because you'd have to become a heavy lifter just to get to the refrigerator. The force of gravity affects not only movement, but also the size of everything. Do you know that many astronauts gain some height due to weightlessness in space? So if you're worried about being short, here's a solution for you. On the other hand, strong gravity would make us all shorter. This would go not only for humans, but for everything on our planet. Trees would become very small. To grow upward, they would have to move water from their roots to branches, which would be unrealistic with such gravity. So they'd all turn into little bushes. Also, no more mountains. Even the largest ones would become very small. But at least now, everyone would be able to conquer Everest. This would also apply to animals. Our pets would have to quickly evolve into pumped-up corgis just to be able to walk somehow. Oh, and say goodbye to birds, of course. If you think that's not enough suffering, let's add another thing. It would be very difficult for us to breathe. Atmospheric pressure would increase dramatically. That's because Earth would start to pull air toward itself with great force. You'd literally feel the weight of it on your shoulders. Remember what I said about taking a break after each step? Now, imagine that you'd also have to breathe through a pillow. Yeah. And that's not all. Atmospheric pressure plays an important role in the behavior of water molecules. It would be much more difficult for water to boil or turn into ice. Most icebergs would melt, and it's possible that we'd have no more clouds, too. All water vapor would come crashing down on us in giant torrents of rain. We'd be lucky if we didn't get flooded instantly. But, oddly enough, there would also be some advantages. For example, everything around us would become much more spacious. Assuming we didn't get flooded, there would even be a bunch of deserted areas on the planet. Maybe land prices would finally fall. But these unexplored areas would most likely remain unexplored, since we'd hardly be able to travel across seas and oceans. Not only because moving across the water would be incredibly difficult, but also because all water bodies on the planet would become 10 times larger. The very thought of getting lost in the ocean is frightening, but imagine if it was 10 times deeper and bigger? Uh-oh. So, no more sailing. And forget about flying by plane, or visiting space ever again. But it seems like it's still not all. If Earth was the size of Jupiter, we'd also have volcanoes raging everywhere. Due to the increase in its mass, Earth would become terribly unstable. All extinct volcanoes would become active again, and there would be lava and poisonous gases everywhere. In 1883, there was the most destructive eruption in the history of humankind, the eruption of the Krakatoa volcano. It occurred on one small island, but people all over the planet could feel the consequences. The eruption destroyed the island, triggered many tsunamis, and clouds of poisonous gases spread for miles. Now imagine this, but 10 times worse. That's what would happen on our Jupiter-sized Earth. It would probably be similar to the fall of the Chicxulub meteorite, the one that wiped dinosaurs off the face of the Earth. Then, poisonous gases spread all over the planet, causing one of the greatest massive extinctions in the history of Earth. Oh, and we would also lose the magnetic field, like the cherry on top of the cake. The magnetic field is very important for life on Earth. According to Rory Barnes from the University of Washington, it shields life on the planet from the nastiness of space, which means all sorts of radiation and solar winds. There's a molten iron core inside our planet that is responsible for producing the magnetic field. If the amount of pressure on this core increased due to gravity, it could solidify. And because of this, Earth's magnetic field would disappear. We would be exposed to the effects of cosmic radiation. Too scary to even imagine. Alright, so now we know that living on this new Earth would be a real nightmare. But what about outer space? You've probably heard that Jupiter, thanks to its strong gravity, protects us from asteroids. Well, this would become our job. Jupiter experiences about 24,000 collisions a year, and now it'd be our destiny. Do you remember me mentioning the Chicxulub meteorite? Similar tragedies happen to our planet once every 100 million years or so. But if it became the size of Jupiter, these guys would visit us every Friday. Also, we'd have to say bye-bye to the moon. Our natural satellite is too close to us. So if Earth grew in size, it would be a real catastrophe. We would literally watch the moon being torn apart in the sky. Of course, after that, all these fragments would crash into us. One of the theories claims that billions of years ago, the moon somehow separated from Earth, and its pieces gathered into a ball. Now, it would be like watching its creation rewind. And even if the moon survived, somehow remaining in Earth's orbit, the changes in the tides would still be dramatic. The consequences of these changes would be very unpredictable, but probably a bunch of tsunamis would be some of them. On the other hand, we'd probably gain a couple of new moons. Jupiter has as many as 79 of them. It would probably be a spectacular view, if only gas clouds from all those volcanic eruptions didn't block it. Also, The appearance of a second giant planet would have significant consequences for the whole solar system. Don't worry, other planets wouldn't crash into us. Many people underestimate just how far the planets are from one another. But still, the new Earth would shift the orbits of other planets a little and affect the rotation speed. And Earth itself would rotate around the Sun much more slowly because of its huge mass. For example, 1 year equals 12 Earth years on Jupiter. All this, of course, would greatly affect seasons and the climate in general. So, would there be life on Earth? Bold of you to even ask this question. But if one day we do manage to find a habitable super-Earth close to Jupiter in size, it would be very interesting to take a look at it.
What would happen if our planet turned into two separate ones, one consisting entirely of land and the other one of water? Could we survive on any of them, and how? Well, you're lucky, because I'm going to answer this question right now. So let's imagine that our Earth has turned into two separate planets sharing one orbit. Let's call these hypothetical planets rock and water. I know, very original. Anyway, let's start with the rock because this one is much easier to imagine. All we should do is ask, what would happen if all the oceans on the Earth suddenly dried up? Now, we know that water is life. It covers 70% of the surface of our planet. There's so much water that even if all the oceans and seas disappeared, some of it would still be left in underground rivers, streams, and so on. But unfortunately, it would not be enough for us to survive. All sea creatures disappear. After some time, all other animals, plants, and of course, people share their fate. Completely dried forests burst into flames sooner or later and burn until there is nothing left but ashes. But hey, it's not that bad. Well, it is bad, but life can still exist in some form. There are some bacteria that make cockroaches jealous. They're able to survive absolutely any conditions. For example, extremophiles have already evolved to live without water. These little guys can survive in an incredibly hot or acidic environment without water or even sunlight. Without them, the rock becomes an empty, lifeless planet. Although, who knows? Maybe someday extremophiles will be able to evolve into some wildly cool forms that can survive literally anywhere. But for now, the rock is just a floating rock, basically. Oh wait, did you imagine a hot desert or some sort of red-hot steppes? Surprise, surprise! This planet is actually extremely cold. You see, without water, there would be no atmosphere. The atmosphere consists of a concentration of various gases, including hydrogen and oxygen. Some H and O, you know where this is going, right? Yep, no water, no atmosphere. And since it is the atmosphere that accumulates all the heat we need, the planet would be very cold without it. The contrast between cold and less cold places also becomes very sharp. You see, water is basically a climate stabilizer. The oceans absorb almost all of the heat of our sun. They distribute it evenly over the Earth to make sure it doesn't get too cold or too hot. So without it, the rock gradually turns into a cold desert. The average temperature on this planet is around minus 100 degrees Fahrenheit. At both poles, the temperature is extremely low, about minus 300 degrees. And even in the warmest places, it doesn't exceed 20 degrees. These warm places are now the former oceans because their dried-up depths are located much closer to the hot core of the planet. Wait, I hope you don't imagine this planet as covered in snow either. We don't have any water at all, remember? It's just a very cold rock. At this point, we're just a bigger and browner version of the moon. The moon is basically a waterless piece of Earth, after all. But hey, what happens to volcanoes? They're basically our last hope to stay warm, aren't they? Unfortunately, volcanic activity is decreasing due to a lack of water. You see, volcanoes and their eruptions happen because of the collisions of two tectonic plates, the oceanic and continental ones. The weight of the water presses on the oceanic plates. They go under the continental plates and form volcanoes. So if there's no water weight, then there's no volcanoes and volcanic activity drops significantly. The rock now is just a planet full of many incredible high mountains. And every time the tectonic plates collide, they form more and more of these mountains and trenches, including some very big ones, like the famous Mariana Trench. I would say, be careful not to fall, but hey, there's no one to fall there. Also, there's no weather anymore. No water means no more snow, ice, or rain, or even clouds. The wind would probably be quite strong, though. Well, that's the fate of the planet rock. Not very bright, so let's just go see how the water planet is doing. Many, many billions of years ago, I wasn't around then, our Earth actually was a planet entirely covered with water. Then, about 1 billion years ago, the sea level dropped. The land appeared. This has changed the atmosphere of our planet forever, and that's how life was born here. But what happens if it returns to its original state? Well, to answer that question, we should first learn more about the ocean planets. So, what does one of these look like? Oh, sorry, I almost forgot. We have no idea. We haven't found any planets of this type because they're incredibly rare. I mean, there is one planet that is low-key and could be called an ocean planet. Yeah, I'm not even going to try and pronounce that. Still, even this one doesn't look the way you probably imagine. The water on it is in a very weird, unique state. Scientists have called this hot ice or superliquid water, and we've never seen anything like this before. In general, though, the actual ocean planets are very hard to find due to many physical reasons. These planets require very specific temperatures, pressures, and so on. But alright, just hypothetically, what would such a planet look like? Well, first of all, of course, it cannot be made entirely of water. I hope you didn't actually think that there could be just some gigantic water blob spinning around a star. It should still be a planet with a core and some kind of foundation. So let's just imagine that all the water on the former Earth has mixed into one giant salty ocean. Wow, that would be a dream come true for the sea creatures, but not for the rest of us. The only animals that could survive in this situation, except fish, are probably the birds that can swim and feed on fish. Now, I think even if the sea level rose significantly, at least a couple of islets could still stay above the water. Such islands would be the former peaks of huge mountains like Mount Everest. So if these birds build their nests there, they can even survive for some time. But what about you and me? Well, we still have a chance. If we had enough time to prepare for the huge flood, we could stay safe either in giant submarines or on giant ships. We can grow food on board and fish from the ocean. But without the Everest Islands, we are unlikely to last long. If something breaks and we have nowhere to dock, we won't be able to fix it. Unfortunately, we no longer have drinking water. Now we can get it only from rain or by filtering seawater. But we have to store it someplace, right? And all these water containers would take up a lot of space and be very heavy. But in general, planet water is not as bad as it might seem. It's quite warm. The average temperature here is about 50 degrees Fahrenheit. And the gap between the lowest and highest temperatures is minimal, from minus 20 degrees at the poles to 70 degrees at the equator. Compared to planet rock, this ain't bad at all. Planet water would also be slightly larger than the Earth in radius due to the volume of, yes, water. The density of this planet would be, on the contrary, quite low. The gravity could become a bit weaker, too. Now, as for both planets, if we place them in the Earth's orbit, after some time, they would still move away from each other and follow different trajectories. They would have aligned themselves not to collide with each other. On one of them, the year would last 12 months, and on the other one, 10 or 11. And that's about it. A fun fact. All of this can actually happen in the future. First of all, the Earth's crust is gradually becoming thinner. Hey, I like thin crust. On my pizza. On my planet, not so much. So, one day, water can really flood our entire land. On the other hand, in a couple of billion years, when our sun begins to expand and turn into a red giant, all the oceans on our planet will really dry up. Alright, take a deep breath and shake it out. That's enough of this grim fairy tale. It's a waste of time to worry about such things so far off when, today, I can't find my wallet anywhere. I thought I put it